to set the precision to 10, 20, or whatever it is really we want. Please note that this is going to be limited by the precision that your type supports. So for example, we know that a double has a precision of 15, and if we have more than 15 digits in here, the rest is going to be garbage. Just be aware of that. We're going to try and build this, and we're going to use GCC as usual. And if we run this, we're going to get our numbers in different precisions. The first one is using the default, which is going to be 6. If we use 10, we're going to get 10 digits. If we use 20, we're going to get 20 digits. But if we go over the precision that our type here supports, we're going to get garbage. I hope this makes sense. The last thing we're going to see is show point, and we have seen that this is used to force outputting the decimal point. Let's say that here. And a good example for that is this 12 here. If we print it out here, we're not going to get the decimal point by default. It's going to print 12. But if we go down and force output of the decimal point, here we're going to get something like 12.0. And another effect of this is that it's going to add trailing zeros to fill whatever space is allocated for your output variable in the terminal. Let's try and run this so that we can actually see this running. We're going to run our Rooster executable. And in the first group here, we don't have the setting for show point. And if you look at the numbers that we had in our code, the first number is 34.1. And you see that we are padding a lot of numbers because we had set our precision to a really big number in the last example that we have run. Let's actually go there and show you that. That's why we're seeing the precision of 20. It is really huge, but no big deal. We can reset this to whatever we want if this is too much for us. The important thing here is that we have 34.1, and that's what we are seeing. And if you go to our 12 here, so you see we have 12.0, but our output is not showing the decimal point here. If it is important to show the decimal point, we can do std show point here, and it is going to show up. This is really what is important in this piece of code here. And this is really all we set out to do in this lecture. We had a chance to play with a lot of these manipulators. And the best way to learn about these things is really to try them out in code and try to change a few things and see how that affects the output you get in the terminal. And we had a chance to play with many of these things in this lecture. There is a lot of these guys. I tried to make this lecture as extensive as I can. That's why it turned out to be pretty long. But once you've learned about these things and played with them in code, you're never going to forget them. One last point I want to emphasize again is that the documentation is of utmost importance. It is really good to come here and check things out. For example, if we go to show point here, we are going to get a nice explanation of what this manipulator does, enables or disables the unconditional inclusion of the decimal point character, and you can read all this. And the nice thing is that if you go down, you're going to have a piece of code that you can use to really understand whatever it is they are talking about. And this is priceless if you are learning. It is a good thing to be able to use the documentation. This is really all we set out to do in this lecture. It turned out to be really long, but I really hope it was worth it for you. We're going to stop here in this lecture. In the next one, we're going to learn about numeric limits. Go ahead and finish up here and meet me there. In this lecture, we're going to be playing with a few functions from this library. Specifically, we're going to be looking at the minimum, the maximum, and the lowest functions. And this is really how you use them. You can think of this t as a placeholder for the type for which you want to know the minimum, the maximum, and the lowest point, respectively. I know this might be cryptic to some of you, so we're going to look at a few specific examples. Here we have a simple explanation of what these functions mean for floating point values. The minimum is going to represent the smallest positive number that is representable with that floating point type. The maximum is going to be the maximum floating point number you can represent, and the lowest number is going to be the lowest negative number you can represent with that type. Things change a little bit when you start dealing with integers, and these functions are going to look like this. The minimum is going to be the minimum number you can represent with that integer, and lowest doesn't really mean anything for integral types. The maximum is going to be the maximum number. One thing you have to keep in mind is that the minimum may be negative if you are using a signed integer. If you are using an unsigned integer, for example, for short, minimum is going to be 0 and maximum is going to be the maximum number representable with that integer type. Here we are looking at numbers for short int, but the same story applies to whatever integer type you are using, even if you happen to be using long int or int without any modifier. Remember that we had to do a lot of things to get this range, and it was really hard to even do this for floating point types. So this library is helpful in getting a sense of what we can represent with a given type, be it floating point or integral. Let's head to Visual Studio Code and play with us. Here we are in our working folder. We are going to copy code from our template project, and we are going to go in the current project, which is numeric limits. We're going to go in, put in our files, go up again, and open this file up in Visual Studio Code. We're going to close this up, open the main CPP file, remove whatever it is we don't need. We are going to include the limits library. Remember, this is the first thing we need to do if we want to play with these facilities that we just looked at in the slides. And we are going to go down here and put in the code we want to play with. And it is ridiculously simple if you have watched the slides we just did in a minute. So what we're going to be doing here, we're going to be printing out the range for each possible type we want to play with here. So we're going to say the range for short int is from, and we're going to say std numeric limits. Short, that's what we want to deal with now, and we're going to call the minimum function. This is going to give us the minimum value we can represent with short, and we're going to say std numeric limits, and we're going to call the max function, passing in the type for which we want to get the range for. And the same story applies for unsigned short. You see, that's the type we are using here. We are also going to play with int, getting the range. We're going to use unsigned int to see how these things behave. We're going to use long and get the range. And we are also going to be playing with floating point types. So we're going to compute the range using the minimum function and the maximum function. And we are going to be also using the lowest function to see that this really is the same thing we described in the slides. We're going to do this for double and long double and see how these ranges come up in this program. What we're going to do is open up a terminal here. We are going to run the test to build with GCC, and the build is going to be good. And we can go down and run Rooster, and we're going to get our values here. The range for short int is from minus 32768 up to 32767. And you see that this is exactly the same thing we saw in the lecture where we talked about number systems. We saw a way you can do this manually by plugging the number of digits in some formula that we came up. You can go back and check that out if you want. We do the same for unsigned short int, and then we look at floating point types. We're going to print the range for float, and if we use the minimum function to get the start of the range, we're going to get the minimum positive number we can represent with a float. If we use lowest, we're going to get the lowest minimum number, and the maximum is going to be the same. If you think this is really small, you have the option to open up this folder in File Explorer, and you can open a command prompt or a PowerShell window by hitting Shift and right-clicking and choosing this option here, Open PowerShell window here. and you're going to get a bigger window in which you can type things. We're going to run Rooster, and we're going to see things in a much easier way here. This is an option you can use, or you can even use the integrated terminal inside Visual Studio Code here, like we've been doing all along. There are a few other facilities you can use in this library of limits. For example, we can try and print out if a number is signed or unsigned, or get the number of digits we can represent in an integer type. These are a few examples I just chose because they are easy to understand and really helpful, but you can find more about this library in the documentation. And if you come here at cppreference.com, the link is here, you can really find all about this library here. This library provides a standardized way to query various properties of arithmetic types. For example, the largest possible value of type int is this. And we have a bunch of things we can do here. Don't be scared off by this template thing. Just think of them as placeholders for the type for which you are trying to query information for. There are a few functions you can call on these things. For example, there is min, lowest, max, that we just played with in Visual Studio Code. But you can see that there are a lot of things you can play with, especially if you have some math background to understand all these concepts here. You can play with this and see if it is helpful for whatever application you are doing. Okay, this is really all we set out to do in this lecture, to learn a little bit about the limits library. It is helpful in trying to understand the ranges for your types. If you happen to need these kinds of things, this is going to come in handy. We're going to stop here in this lecture. In the next one, we're going to learn about some math functions we can use in C++. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about math functions. And these are functions that are built into the C++ standard library that we can use to do some math. If you are doing some math operations, you're going to find these helpful. They live in the C math library. And if you want to use them, you're just going to include that and you're going to have access to them. What you see here is a simple summary of some of the things you can use in these math functions. You can use stdfloor to round down or stdceil to round up. You can use the abs function to compute the absolute value of a number. You can do trigonometry, you can do the cosine, sine, and things like that. You can compute the exponential of a number. You're going to see what this means in a few lectures. You can use stdlog. And again, if you have some math background, these concepts are not going to be foreign to you. Many of these functions are documented here at CPP reference, so it might be worthwhile to go there and check what functions are available there. Here is an example of something you might want to do. For example, you have a variable, it's called weight. Inside we have a 7.7, and if you do stdfloor of this variable, this is going to be rounded down to a 7. If you want to round up, you're going to use stdceil and you're going to get that, and we're going to see what this is going to give us in a minute when we hit Visual Studio Code. Here is how you would use the absolute value function. You have a few variables here, and if you try to plug them in, this absolute value function, you're basically going to get the weight of the number without any sign in front of the number, positive or negative. The absolute value is the weight of the number without caring about the sign, if I may say it like that. Okay, we also have the exp function, which is going to compute the exponential of a number. This is a math concept, so if you don't have a background in math, this is going to be a little hard to wrap your brains around. But in math, we have this number, which is called e, and its value is approximately 2.7 1828, like you see here. The exponential function is going to do what fx here is doing. It's going to take e and elevate that to the power of x. And for example, in our code here, we're going to get the exponential of 10, which is going to be e elevated to the power of 10. And we're going to play with this in Visual Studio Code, and you're going to see the value of this. We also have the power function here, which is going to take the first parameter and elevate that to the power of the second parameter. So This is going to be 3 to the power of 4 and 9 to the power of 3. And we're going to get the answer if we plug this into Visual Studio Code. And we have log functions, which is basically the reverse of the power function that we just looked at. If you do log 8 in base 2, for example, it is like you are asking, to which power should I elevate 2 so that I get 8? And the answer here is going to be a 3, of course. But the catch is that the log function by default works in base E. So what we are asking, for example, if we say log 54.59 is to which power should we elevate E to get this number in here? And it is going to be computed, and you're going to see this if you plug this into Visual Studio Code, or you can try to use one of the calculators available to you, and you're going to see that this makes sense. We also have a special function that is going to do the same thing, but in base 10, and this is going to be easier to understand. For example, here we are computing log 10. So what we are really saying is to which power should we elevate 10 to get 10,000? And this is easy because the answer is 4. 10 to the power of 4 is 10,000. I really hope this makes sense. We also have a square root function we can use. So square root of 81 is going to be 9. We have a function called stdround, which can round. And what it's going to do by default, halfway points are going to be rounded away from 0. So if you have a 2.5, it's going to be rounded up to a 3. And if you have 2.4, it's going to be rounded down to a 2. We also have a host of functions we can use in trigonometry. We have a sine function, we have a cosine function, we have a tan function. If you know these concepts in math, this is going to come in really handy if you want to do this. I have to say that what we just talked about is a small set of what we can do with these functions here in CMath. And we are here at cppreference.com, and we can see all these functions here. We can do reminder, we can do fmin, and if you want, you can check this out in the documentation. For example, if you go to tan here and click on it, you are going to get the description and explanation of what this function does, and you're going to have a simple example of how you can play with us. Okay, now I hope you have a better idea of what we can do with these functions in the CMath library. We're going to head to Visual Studio Code and play with some of these functions. Here we are in Visual Studio Code. The current project we're going to work on is math functions. We're going to copy over our template files, and we're going to put them in our directory here, math functions. And we are going to open this up in Visual Studio Code, and we are going to remove whatever it is we don't need, and we are going to include our library, which is CMath, and we are going to put in our code so that we can play with us. And here we have a variable called weight, and we're going to try and use a few math functions on it. So we can use stdfloor to round down and stdceil to round up. So weighted rounded to floor is going to be printed out, and weight rounded to ceil is going to be printed out. We're going to have a number here. In this savings variable, it's going to be a negative number, and we're going to try and compute the absolute value of this. We're going to see it printed out. Another thing we're going to compute is the exponential of the value. We're going to do stdexp10. And what this is going to do is going to take e and raise it to the power of 10. And that's what we're going to get printed here. The other thing we want to do here is compute the power of a number. We're going to take 3 and raise it to the power of 4. And take 9 and raise it to the power of 3. And we're going to see what these things evaluate to. We're going to open up our terminal here, and we're going to run the task to build with GCC. The build is going to be good, and if we run Rooster, we're going to get these things here. So 7.7 rounded to floor is going to be 7, so we're going to round down. 7.7 rounded to ceil is going to be 8, and that's what we're going to get. And the absolute value of weight is going to be 7.7 because it is a positive number, and the absolute value of minus 5,000 is going to be 5,000. And again, when you compute the absolute value of something, you are interested in the weight of that thing without considering the sign, without really worrying if it is positive or negative. You just want to get the magnitude of a number. That's what we use in math to mean that, magnitude. Okay, so if we go down, we're going to get the exponential of 10 is exponential, and you're going to get that here. And again, what this function does is take e and raise it to the power of 10, and that's the answer here. We can try and prove this with a calculator. So I am going to open my Windows calculator. You can use whatever calculator you have access to. I am going to use a scientific calculator here, and you see that we can hit E, and we're going to get the value of this E number in math. Here it is simplified, but if I take it and raise it to the power of 10, the answer is going to be 22.026. And if we look in our program, we have 22.026.5. Okay, it is rounded up a little bit, but it is almost the same thing. Okay, we also want to play with log functions a little bit. Log is basically the reverse of the power function. And we just talked about this in the slides, but if we do log 8 in base 2, we are basically asking to which power should we raise 2 to get an 8? And the answer to that is going to be what this log number in base number is going to evaluate to. The catch is that the log function, if you use it row like this, it is going to be using base e. And we just saw that e is 2 to the power of 7 or something. Let's go back to our calculator and see if we can see that. Why not? Why try to guess when we have a good calculator in our hands? We are using the scientific calculator. So if we hit E here, this is the value of E. Okay, so when we do log, we are basically asking to which power should we raise E so that we can get this 54.59. And the answer is going to be computed and printed out here. We have a version of this that is going to use base 10. So if we use this, we are basically saying to which power should we raise 10 to get 10,000, and the answer is going to be printed out here, and it is going to be a 4 because this is easy to do in your mind. So let's run this. We're going to build the task. We are going to run the task to build with GCC, and we're going to run our program, and we're going to get our output here. To get 54.59, you would elevate e to the power of this number here. This is the answer. And if you want, you can prove this with your favorite calculator. You're going to get something close to this. To get 10,000, you'd need to elevate 10 to the power of 4. That's what we're going to get in here. Let's print this out. Again, many mistakes. Sorry, but I hope you get the point. If we build again so that we can see things properly and run, we're going to get proper data. And this is really what we expected to get. We have a few more functions we can play with as we saw in our slides. Let's play with square root and the std round function. Here we are going to get the square root of 81. We're going to get it printed out, and we're going to see what std round does. It is going to round away from 0 if we are at half point, and if we are not at half point, if we are below that, we're going to round down. If we are higher than that, we're going to round up. We're going to run this so that you can see this running, and we're going to call rooster, and 2.5 is rounded to 3, 2.4 is rounded to 2, 3.6 is rounded to 4. This is what we expect, and the square root of 81 is 9. This is really all we set out to do in this lecture, to play with a few of these CMath functions. They are not really hard to use once you have the basics of math nailed down. And again, if you want to check the full list of these functions, please come to our reference documentation here. You're going to find a lot of them. And if you want to see how to use one of these, for example, if you click on log 10 here, You're going to come here, you're going to get an explanation of the function, and even better, you're going to go down and get a nice piece of code you can play with and really make sense of what is happening in these functions here. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to learn about some weird integral types. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about some weird integral types. And what do I mean by this? Well, if you look here, integral types less than 4 bytes in size don't support arithmetic operations. And these are operations like addition, subtraction, multiplication, division. You can do these operations on those types. And here I have an example of some of those types. We have a car. It is 1 byte in size, and short int is 2 bytes in size on most processors. So you can't do arithmetic operations if your integer value is stored in these types. Why is that? Well, this has to do with processor design, and they decided to choose int as the smallest type, integral type, for which they can do these arithmetic operations. But compilers are really smart enough to notice if you are trying to do arithmetic operations on these types, and they are going to implicitly convert from these smaller types to int. And this is something you need to be aware of. If we look at this program here, for example, we have var1 and var2. They are stored in variables that are of type short int. And we have var3, var4, which are stored in a variable of type char. We can try and print the resizes, and we're going to get 2, 2, 1, 1 for these variables because a short int occupies 2 bytes in memory for my computer here, and the char occupies 1 byte in memory. But the catch is down here. If you try to add them up, the result is not going to be the same type as the things you added up. And you would expect auto to deduce to the same type as var1 and var2. And it's not. Result is going to be an integer because int is the smallest type for which we can support these arithmetic operations. So if we print size of result 1 and result 2, we're going to get 4. But this is the behavior you're going to get, and we need to be aware of it. The same behavior can be observed on other operators that we will have a chance to look at in a few chapters ahead. And these are called shift operators. You use them to shift bits. But I don't want to talk any more about them because we're going to have a chance to learn about them in detail. Okay, now is time to head to Visual Studio Code and actually see this in action. Here we are in our working directory. We are going to copy our template project. We're going to copy this, quickly put that in our folder on weird integral types. This is our current project here. And we're going to open this up in Visual Studio Code. We're going to open this up, and we're going to open our main CPP file, remove whatever it is we don't need. And we are going to put in our code. This must be very familiar because it is what we just saw in the slides. So what we are doing here, we have 4 variables. var1 and var2 are short int. So these are going to take 2 bytes in memory on my computer here. And char is going to take up 1 byte. And we're going to print the resizes. We're going to see them printed out. And we are adding things up here. We are taking 2 short int variables and adding them up. So what the compiler is going to do, it's going to take this, turn it into an int, and then do addition, and the result is going to be an int. The same story is going to happen for result 2 here. var3 is a char, so it is 1 byte in memory, but the compiler can't really add up integral types which are smaller than 4 bytes in memory. So what is going to happen? var3 is going to be transformed implicitly behind the scenes to an int, and var4 is going to be transformed to an int, and then we're going to add that up, and we're going to store that in an int variable, which is result here. If we print this up, we're going to see that size of result 1 and result 2 is 4, and this is what we expect here. And this is a behavior you need to be aware of because sometimes your application logic is going to depend on the size of data. If that's the case, you need to care about this. And if you don't know this, you're going to be beaten by this. And it is really hard to find problems like this. So what we can do is open up our terminal, and we're going to build this with GCC as we usually do, and we can run our program Rooster, and we're going to see that this is what we expect. var1 is 2 bytes in size, var2 is 2 bytes in size, var3 and var4 are 1 byte in size, but our result is 4 bytes because the compiler implicitly converted our operands here to ints to be able to carry out this arithmetic operation. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to try and recap what we saw in the chapter. Congratulations on hitting the end of this chapter. And this chapter was really about doing operations and manipulating the data that you have stored in your variables. The first thing we saw was that we could do arithmetic operations on the data. We can add things up, multiply, divide. We also saw the modulus operator, which may seem weird for beginners, but we had a chance to really play with us. After that, we learned about precedence and associativity. We saw that that's a set of rules we have to follow to know which operation to do first if we have multiple operators in our expression. We also had a chance to learn about prefix and postfix increment and decrement operators. We had a chance to do compound assignments, things like plus equal, minus equal, multiply equal, modulus equal. Now these things must be making sense to you. We had a chance to look at how we could compare things using relational operators like greater than, lesser than, and equal or not equal. We also had a chance to look at output formatting, and we saw a host of things we could do to make data show up better with stdcout. After that, we learned about numeric limits, and this is a cool way to know the ranges for your data types, but there are a host of other properties you can use in this limits library. We learned a little bit about math functions, and we played with things like the power of something, the exponential, the few rounding functions that we have in the CMath library. And now you must have a good idea about these functions that you can use to manipulate and do math on your variables. We ended the chapter by looking at some weird integral types, and the main message in that lecture was that you can't do arithmetic operations on data types whose size is less than 4 bytes in memory. If you try to do that, the compiler is going to insert implicit conversions, and if your application depends on the size of things, this is something you need to be careful about. Otherwise, you're going to have a hard time finding these problems. I would like to welcome you in this new chapter where we're going to be learning about a new way we can do things in C++, and we're going to be doing conditional programming. In other words, we're going to be able to do different things based on the conditions that we have set up in our code. Just to give you an example here, we have a few variables, they are booleans, and we have a few initializers in there. Red is false, green is true, yellow is false, police stop is true. And we can do different things based on these Boolean conditions. For example, if the light is red, we may be told to stop. If the light is yellow, we might be told to slow down. If the light is green, we might be told to go and do whatever it is we want to do. So we're going to be able to do these kinds of things. And C++ provides different constructs to be able to do conditional programming in your C++ code. We just have one of them in this slide, which is this if statement here. This if keyword allows you to do things like this. We have a few others. We have the else keyword, we have the switch keyword. We also have a completely separate operator that is called ternary operator that allows you to do these kinds of things. And we're going to be learning about all these things and more in this chapter. We are going to start and learn about the if statement in this lecture. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about the if statement. And this is a statement that is going to allow you to do things based on some condition being true or false. Here is a simple code example. We have two variables, number 1 and number 2. And we have a statement here that is going to compare number 1 and number 2. And we're going to store the result in this Boolean variable that we have on the left. Then we're going to do something based on the value that we are storing in this result here. If the result in there is true, we're going to print number 1 is less than number 2. If the result is not true, we're going to say number 1 is not less than number 2. And notice in the first if clause here, we are testing for the case where the result is true. But sometimes we need to do something when this condition here is not true. One way to do that is to negate what we have here inside the if parenthesis and test for the reverse of whatever we have in here, if that is making any sense. If you look here, we are testing for the case where if not, the result is true. And in other words, we are testing for the case where the result here is false. And we're going to say number 1 is not less than number 2. This is one way we can go about this. Again, the if statement is used to do conditional programming. This is the syntax we use to do it in C++. We say if, we put a set of parentheses, and inside the parentheses, we put the condition we want to test for. And after that, we're going to have a pair of curly braces. And what we have inside these curly braces is going to be the body of our if statement. And it is basically going to be the code we want to run if the test here is successful. We can also use an else clause to catch the case where the test hasn't been successful. In this case, we can say if result equals true, we're going to do something, and else, we're going to do something else. In other words, if result is true, we're going to say is less than. If it's not true, we're going to say is not less than. And this is a more compact way of doing what we just did in the slide here. You can also directly use your expression as a condition. And the requirement here is that the expression evaluates to something that we can treat like a Boolean, because the condition has to be a Boolean. It has to be true or false. Okay, here is another simple example. We have seen this in the last lecture. We have a few variables containing our conditions, and we are saying if the light is red, for example, we're going to do something. If it's yellow, we're going to do something. If it's green, we're going to do something. We can also nest conditions. For example, we can put our outer if statement, and inside that if statement, set up other if statements. And if our logic needs something like this, you can do this and you can take advantage of this to achieve whatever it is you want to do. In this case, if the light is green, we're going to fall in here and we're going to do another condition. So if the light is green and if the police officer has stopped you, you're going to stop. And if they haven't stopped you, you're going to go because the light is green. And you can do something like this. We can also use logical operators to kind of achieve the same thing. And we say, if the light is green and the police officer hasn't stopped you, you're going to go. Else, you're going to stop. And you can do something like this. And you see that you can combine the logical operators we've learned about with the conditional programming techniques we are learning about here to do really powerful stuff. And we're going to be doing this all over the place in the course. So we're going to head over to Visual Studio Code and play with us. Here we are in our working directory. We're going to be working on if statements, and we're going to grab our template project, the template files, I should say, and we're going to put them in here. And we're going to open this up in Visual Studio Code as we always do. So let's do that. Open folder, and we should fall in here and open our main CPP file. Let's do the usual and remove what we don't need. And we are going to put in our code so that we can really play with us. We have two variables in here, number 1 and number 2. They are integers and we have the values 55 and 60 inside. We can do a comparison between these two variables, and what this comparison is going to yield is a Boolean value that we're going to store in our Boolean variable here, which is called result. And what we can do is use this to do some conditional programming. So we're going to say if the result is true, we're going to do something. And if the result is not true, we're going to do something else. And this is how we say it. This syntax here may be confusing to new students, but try to think of it. If not, result is true. And that's really the same thing as saying if result is false. try to spin this in your mind a little bit and you're really going to understand. Okay, so now that you have seen this piece of code, try to guess what we're going to see if we run this. What are we going to see on the console? Okay, give it a try. So we're going to run this in Visual Studio Code. Let's open up a terminal first. And we're going to build with GCC as we always do. We're going to bring this up a little bit so that we have some breathing room. And we're going to run Rooster. Let's see what we have here. We have result equals true. And that's coming from this statement here. And we have freestanding if statement, which is coming from here. And we have our meat of this program, what we really are interested in. We have 55 is less than 60. So our test here succeeded, and we fell in this body and executed this stdc out statement. That's why we're saying number 1 is less than number 2. And number 1 is 55, which is what we see here. And number 2 is 60, which is what we are seeing here. So what can we do to make the second statement here execute? It is testing for the case where not result is true. So it's going to exactly do the reverse of what this test here is doing. And if this fails, this one is going to succeed, which is what we have now. So what we can do to really play with this, we can go up and change, for example, number 1 to 65. This is going to flip the order of these numbers, if I may say it like that. And if we run it, we're going to build with GCC and run this. We're going to see result is false. So result became false because number 1 is not less than number 2. So this is going to be false. And the test here is going to fail. Result is not true, so we're not going to go in here and look at here. If not, result is true. So result is true is false. If we negate this, this is going to become true, and this test here is going to succeed, and we are going to fall in here. Take some time to really understand this, and if you have a problem, ask me. I am going to do the best I can to help you out, but make sure you understand this, because this is really fundamental in your journey as a software developer, not just in C++. Any career as a software developer, you're going to need to understand this. Okay, what we're going to do is comment out what we just did here, because we're going to see another way to do this, and we don't want to have noise output in our terminal. This is going to just make things hard for us to see. So what we're going to do, we're going to go down in here and put in another piece of code. And the result was commented out. We don't want to comment that out, so we're going to take this out because this is our condition. We're going to grab it and put that outside our comment section. This is going to do. And if we go down again, we're going to click on this file icon and give ourselves some more breathing room here. We don't really need to see that main CPP file anyway. So if we come here, we can use the else clause to test for the case where our condition fails. And if you look here, we are essentially saying the same thing. We are saying if result equals true, we're going to fall in here, and else we're going to fall in here. So we don't need to do the double if statements that we just did here. And this is much more compact and easy to read. Let's look again at the numbers we have here. Number 1 is 65, number 2 is 60. This expression here is going to be false because 65 is not less than 60. We're going to have a false in here, and if we come down, result is going to be false. This is going to fail, and we are going to fall down here. We're going to say number 1 or 65 is not less than 60, which is what we have in our values. So we're going to build this again, and we're going to run Rooster. That's clear so that we have some breathing room. We're going to run Rooster, and you're going to see that 65 is not less than 60, which is what we expect. Again, if you go up and change these numbers to whatever you want, try to change these numbers to different values to see what you get as output. If we do this, we're going to see that number 1 is less than 60, so this is going to be true, and we're going to have a true in this result variable here. If we go down, result is true. This test condition here is going to succeed, and we are going to fall in here. Let's click in our terminal and hit enter. We're going to run Rooster. We're going to see 55 is less than 60, which is what we have here. Okay, now I hope you have a better idea of how you can use the else clause to make your if statements really compact. And this is really cool. Okay, another thing I want you to see is that you can not go through a variable like this and use an expression as a condition directly. C++ allows you to do this. So what we're going to do, we're going to comment out what we just did. Let's do that. I'm going to use a block comment. I hope you know how to use this already. And we're going to go down and put in our code. It is exactly the same thing, but we took the expression and put that in the place of our condition variable here, because this is going to evaluate to a Boolean anyway, so we can use this as a condition, and this is something very legal to do in C++. So if we run this, we're going to see, let's see what we have in the numbers. I have forgotten by now. So 55, number 1, 60, number 2. Number 1 is less than number 2. This is going to be true. So the test here is going to succeed, and we are going to fall in here. That's what we're going to say. We're going to build with GCC as usual, and going to clear and run Rooster, and you're going to see that this is the output we expect. If we change up the numbers again, let's take this and make it a 75, number 1. So number 1 is less than number 2 is going to evaluate to false. The test here is going to fail, and we are going to fall in this block here. We're going to fall in the else clause of our test here. We're going to say 75 is not less than 55. Is that what we have in there? It's a 60. But this block here is going to execute. That's the most important thing. So we're going to run this, and we're going to try and clear and run Rooster. We're going to get what we expect. This is one way we can do this, and it is really cool. Let's comment this out and see another example. And if we go down, we can see the example we saw in the slides, which was using red, green, and yellow to simulate a traffic light. So what we really want to see here is that we can nest stuff, but before we do that, we need to try and use these conditions because it is just fun. So if red is true, meaning that the red light is on, we're going to stop. If yellow is true, we're going to slow down. If green is true, we're going to go. And if we look at what we have here, red is false, green is true, false is true, and a police stop is true. Police stop is not really being used. So green is true, we're going to execute the green statement here, and we're going to say go. That's what we're going to say. Let's try and run this. We're going to build with GCC, bring this up a little bit so that we have some breathing room. And we're going to clear and run Rooster. And you see that it is saying, go here. You can try and change these Boolean variables to different things and see what is printed out here. This is a great way to learn. But what we really want to try here is nested statements. And let's go down and do that. Okay, so again, we don't want what we have on top here to disturb us, so we're going to comment this out, and we are going to go down and put in our code for nested if statements. So what we're going to say is if the light is green, we should go, but the police officer has the right to stop us even if the light is green. At least these are the laws in the country where I live. So we have a variable called police stop here. So if they stop you, even if the light is green, you're going to stop. And we're going to see what we see here. So if the light is green, we're going to fall in this body again, and we're going to run this inside or nested if statement. And if the officer has stopped us, we're going to stop. If they haven't stopped us, we're going to go and go on our merry way. This is what we want to see here. And again, I want you to stop for a moment. Try to run this through your brain and try to come up with the value we're going to see when we run this in Visual Studio Code. Pause for a minute. We're going to run this. We're going to build with GCC, and we're going to run our program, and you see that police officer stops, stop. And why is that? The light is green, okay, so we should usually go, but the police stop variable here is also true. So if we fall in here, this is going to execute and it is going to succeed, and we are going to say stop. And once this statement executes, the else statement is not going to execute. Control is going to fall outside here, and we're going to keep doing whatever we have outside this if statement here. This is really critical to understand. If one block of an if statement succeeds, all the others are not going to execute, and try to really understand this. Okay, we have seen this. We can now comment this out because we have something else I want to show you. We're going to comment this out. And that's that you can combine the if statements here or conditional programming with the logical operators we have learned about earlier in the course and do really powerful stuff. For example, here we can actually not use these nested statements and do this in one go like this. And I think this is much cleaner. So we're going to say if the light is green and the police officer hasn't stopped us, we're going to go. And if they have stopped us, we're going to stop. And you're going to see that we're going to get exactly the same result that we had before, but this is really much more compact. So we're going to run and see the result of this. And we're going to clear, and run Rooster. You're going to see that they're going to stop us. And this is really cool. You can go up again and change up these variables to really anything you want and see what you get and try to really understand what is going on here. It is not difficult. And the if statement is really fundamental to any programming you're going to do. So this is really all we set out to do in this lecture, to learn about conditional programming using the if statement. It is a powerful thing, and you're going to see it all over your software development career. So make sure you really understand this. But even if it's not clear now, we're going to have a chance to do many examples, and you're going to really understand what this is all about. We are going to stop here in this lecture. In the next one, we're going to see how we can use the else if clause. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about the else if clause that you can attach to your if statement. And that's going to allow you to test for several conditions in your if statement. And to really understand this, suppose we are building a drawing application. And at any given moment, the user might be using the pen or the marker or the eraser or really whatever tool that it is we provide in our application. And if we want to draw, we need to know which tool is currently selected by the user. And we can do a piece of logic like this. We can have the tool stored somewhere in our application. And when we get to the moment where we want to do something, for example, when the user clicks with their mouse and they want to drag and start doing things, then we're going to test for the current tool. If the tool is the pen, we're going to use the settings for the pen. If the tool is the marker, we're going to use the settings of the marker. And we're going to keep doing this and select one tool that is actually selected as the current tool by the user. And when you do something like this, only one block in this whole chain of statements is going to execute. So for example, if we have the marker as the current tool, the code inside this block is going to execute and say active tool is marker, but nothing else in this block is going to execute. After we run this statement, control is going to jump at the end of this whole chain of if and else if statements here. I really hope you understand this. And this is really powerful stuff. For example, this is one of the applications I have done in one of my advanced course about Qt and C++. Qt is a framework that allows you to do graphical user interfaces like this, and you can build applications like this. So what I did here is I did the exact same thing that we have here. I had a chain of if and else if statements, and whatever tool was selected as the current tool was used to draw things on the canvas here. For example, if the current tool was the pen, and the pen is this little pen tool here, if it is active, we're going to draw things like hello world here. If we have the stars selected, we're going to draw stars. If we have the rectangle selected, we're going to draw rectangles. We could do all kinds of crazy things using this piece of logic here. But it is powerful stuff, and you really have to make sure you understand this. So this is how the else if clause can really help you. The main thing is to allow you to test for several different conditions. You could do this with a lot of if statements, but that's not going to be really cool. It's going to be ugly and hard to read. This is what you should do. Now that you have an idea about this, we're going to head to Visual Studio Code and actually see this in action. Here we are in our working directory. We're going to grab our template project pretty quick, and we're going to use the else if project here. That's our current project. So we're going to do that and open this up in Visual Studio Code as we always do. We're going to open this up. We're going to open main CPP, and we're going to remove what we don't need. The first thing I am going to do is to put in a set of variables that are going to store our tools. And we can do something like this. We have a variable for pen, marker, eraser, rectangle, circle, and ellipse. I have to say that this is not the way to go about this. We're going to learn about another way we can do this, but that's going to be later in the course when we have enough tools to understand this. For now, we're just going to be happy with this. Okay, 10 is going to represent the pen, 20 is going to represent the marker, 30 is going to represent the eraser, and we can go on until we hit ellipse, which is represented by 60. Now, if we go in main and set up a variable and call it tool, for example, and initialize it with whatever tool we think that the user is currently using, for example, we can use circle, and initialize this, we can set up a chain of if and else if statements to do whatever it is we want to do when this tool here is selected. Okay, we're going to go down and put in our code. I don't want to type all this, so I'm going to put this up here. And if you want, you can copy the code from the resource section. The code is going to be there. You can copy it and paste it in here and do things with it. Okay, we have a chain of if and else if clauses in here. And the first one is going to test and see if the tool is the pen. And notice that we are using double equal signs here. This is what you use to test for equality. You don't use one equal sign, you have to use two equal signs. If you use one equal sign, that's going to be an assignment, and this is going to always evaluate to true, so you don't want to do that. Again, to test for equality, you're going to use double equal signs in C++. So if the current tool is the pen, we're going to say active tool is pen. If the current tool is marker, we're going to say that. So we are basically going to do this for all the tools that our application supports. So what do you think we'll see when we run this? The active tool is circle, so we should print active tool is circle here. Let's try this out. We're going to open the terminal so that we can see the output nicely, and we're going to build with GCC, and the build is going to go through. If we run this, we're going to see active tool is circle. You can go up here and change the tool to rectangle, for example. If you build again, you're going to see that the correct block of code is going to be executed. We're going to clear and run rooster. Active tool is rectangle. If we try to put in something that doesn't exist, let's put in bird. Just to mess with our compiler here, we're going to get a compiler error because that type is not known by our code here. So we're going to get bird was not declared in this scope. We don't know what it is. You have to put in whatever thing you have declared beforehand here. So if we put in eraser, for example, we're going to build with GCC. The build is going to go through, going to clear, run rooster. The tool is going to be eraser, and this is exactly what we expect. Again, the main message in this lecture is that you can use this else if clause if you have several conditions that you want to test for, just like we have here. And again, one of these blocks is going to execute, and once we hit the end of this chain of if and else if clauses, we're going to fall here and code after that is going to execute. So let's say moving on so that you can really see this here, very clear. Moving on. And if we build this, we're going to see only one block from this whole chain. And once one block executes, control is going to go after all this chain and execute whatever is after that. So we're going to say moving on after we print that the active tool is eraser here. I think we have built this, so let's try and run this. And you see active tool is eraser and moving on. So after we print the code from the eraser block, we're not going to execute rectangle or circle or ellipse. It's going to jump at the end of this whole block. This is really what I want to be super clear. And again, make sure you understand the syntax here. The else if statement is followed by a set of parentheses. And inside the parentheses, we have the condition we want to test for. The condition has to evaluate to Boolean. And after that, we have the block of code that we want to execute. And this is really all you have to do to get this to work to your advantage. We are going to stop here in this lecture. In the next one, we're going to learn about switch. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about the switch statement. And this is an alternative way to do what we did with these else-if clauses in the last lecture. Basically testing for several different conditions, but it's going to be in a much more compact way than what we did in the last lecture. We are going to be using the exact same example we did in the last lecture, and we're going to look at the switch statement and how it works in C++. And this is how it works. We have our variable which is going to store the current tool, and we're going to say switch. Inside the parentheses here, we're going to pass the variable that we're going to be basically switching on or testing the conditions on. And inside the block, we're going to be basically testing for each case. So we're going to say if the current tool is the pen, we're going to say case pen. We're going to put a colon in here, and we're going to put the code we want to execute for the case where the current tool is the pen in these curly braces here. And one thing you should notice from the start is this break statement here. This is a statement that tells C++ that after we successfully execute a block of code, we're going to jump out of this switch statement. If you omit this break statement, everything after the case that you just executed is going to execute, and that's not probably going to be what you want. If this is not making sense yet, please bear with me. You're going to see it run in Visual Studio Code and you are going to understand. So what you're going to do, you're going to put all the tools you want to test for in separate cases. You see here we have marker, and after that you can put a default case that is going to be matched when nothing has been matched in whatever it is you have tested for in this switch block here. And when we run this piece of code, we're going to get exactly the same results that we had in the last lecture, but hopefully you can see that this is much more compact than the series of else-if clauses that we had in the last lecture. Again, the break statement is really useful. If you don't put it in, C++ is going to be confused, and after you hit your successful case, everything after that is going to be executed. So the break statement is basically telling C++, if you hit it after a successful case is executed, jump out of this switch block because you are done. You don't have to do anything else in here. And another thing you should know is that the condition, which is what we have inside these parentheses here, can only be an integer or an enum. So basically it can be int, long, unsigned, or char. Basically every integral type we have seen before, but it can't be another type such as string because that doesn't really make sense. So be sure to keep this in mind. Now that you have an idea about this switch statement, let's head to Visual Studio Code and actually see this in action. Here we are in our working folder. The current project is going to be switch. So we're going to grab our template files and we're going to bring that in here. We're going to go up a little bit and open this up in Visual Studio Code as we always do. And we're going to open up our main file. We're going to get rid of what we don't need. We are going to go outside the main function here and put in our tools, just like in the last lecture. We are using integers. Each one is represented by 10, 20, 30, up to 60. And these are the tools we have. And I don't think I explained this, but we are flagging them const because we don't want them to be modifiable. We have seen about const earlier in the course. We are going to jump into main and set up our variable. It's going to be int, and we're going to call it tool. And we're going to initialize this whatever tool we want. Let's use eraser, why not? And then we're going to put in our switch block. We're going to say switch. And if I type this, you see that Visual Studio Code is going to give me IntelliSense or suggestions on what thing I could do. One cool thing that Visual Studio Code does is give you snippets to really help you type things out. So we can click on this and it is going to autocomplete a starter version of our case. And we can type in our expression here, which is going to be what we're going to be switching over. So we're going to switch over the variable tool here, and we can put in our cases. So in our case, we're going to start with pen, which is what we have here. So we're going to say case pen. We're going to remove all this. Let's remove this and say pen. Going to put a colon, and we're going to put a block of code that is going to execute when the current tool is the pen. And we're going to put that in here. Let's bring this to the right a little bit. And inside the block, we can say stdc out active tool is pen. Okay, so after that, we're going to put this break statement. If it's not here, we're going to have a problem, because when the current tool is the pen and this code here executes, every case after that is going to execute, and that's not what we want. We have to remember to put this break statement here. Okay, so we're going to put in all our other cases. So we're going to copy this and look at the next one. It's going to be marker. So we can go on the next line and put in marker. We're going to paste this in. We're going to say marker, and we're going to say active tool is marker, and we can keep doing the same thing. We're going to go down a little and paste this in. The next one is going to be eraser, so let's do that. We're going to say eraser, and we're going to say current tool is eraser, and we're going to go down again. I am doing this live because it really is important for you to see me type this. Otherwise, you may be confused, because this is a slightly confusing construct we have in C++. The next one is rectangle, so we're going to use that, and we're going to say current tool is rectangle. The next one is going to be circle and ellipse. So let's do that. We're going to put in circle, we're going to go down and paste this in, and bring this back a little bit, and we're going to say circle. And we're going to go down and put the next one in, which is going to be ellipse. And after that, notice that Visual Studio Code also inserted a default block. And this is a block that is going to execute when none of the cases here is hit. So this is really important. So you can also add a block of code and say no match found. Okay, so we want to see this print out, and we're going to try this out in a minute. Okay, after we do this, we should get this to work and do whatever we were doing in the last lecture. So the current tool is going to be eraser. The block here is going to be matched, so code here is going to execute. After that, we're going to meet this break, and what it's really saying is, you have done what you have to do, jump out of this switch block here. And we're going to go to the end of this switch block, and we're going to execute whatever is after that. So just like in the last lecture, we can say moving on. And if we execute the program as we have it now, it's going to say active tool is eraser, and it's going to print moving on. Let's bring up the terminal so that we can really see this. And we're going to build with GCC. The build is going to be good. And if we run Rooster, let's clear a bit. We're going to see that active tool is eraser, and we are moving on. This is really cool, and it is exactly the same thing we had in the last lecture, but now we are using a much cleaner construct which switch provides. Okay, we can try to change the tool and see that this really works. We can put in circle. Why not? We're going to build with GCC. The build is going to go through as you see here, and if we run Rooster, we're going to see active tool is circle. We are moving on. You can try and change this however you want. If we put in ellipse and build again, we're going to build with GCC. And if we run, we're going to get active tool is pen and moving on. Why is that? Ellipse, we are saying active tool is pen. We didn't change that. So we just code a really bad bug here. So let's fix this. And we're going to build again. I'm glad I found this. So we're going to clear and Rooster. And we're going to see active tool is ellipse, and we are moving on. Okay, so let's see what could happen if you forgot your break statement after your case here. So the current tool is ellipse, and it is the last thing we have in here. So it's not a good test case. What I am going to do is make the current tool the pen or the marker. Let's use marker. That's going to do. And I am going to remove the break statement here. Okay, so, and I am going to remove all the break statements we have until we hit the last default case. So we're going to go down, and we're even going to remove that for the default case here. And if we build, we're going to build fine. You're going to see that the build was good, but if we run this, try to guess what we're going to get. The current tool is the marker, so we should print marker and hit the end of the switch block and do moving on. But let's see what we get. Did we build? Let's build again just to be sure. So we're going to run Rooster, and notice what happens. Active tool is marker, active tool is eraser, active tool is rectangle. We basically print every other case after the marker case is hit. And if we try to change this, for example, not use marker and use eraser, let's change this. You're going to see that we're going to match the eraser case, and everything after that is also going to execute, and it is not what you want. So let's clear and run Rooster. You're going to see eraser, rectangle, circle, ellipse, and no match found. So you have ready to remember to put in these break statements. I am going to hit Ctrl-Z a couple of times and bring those in, and I think this is enough. We have to hit again so that marker also has it. And if we run now, we're going to get what we expect. Let's try to use an eraser again, and if we build again and clear and run Rooster, we're going to see active tool is eraser, and we are moving on. This is what we expect. Okay, this is really how you work with a switch block. You have to pass in your expression or your test case, and you catch each case using this case syntax here. You say case, you pass in whatever it is you want to match, and you put a colon, and you put your code inside this block here. And remember, after each case, you have to add this break. Otherwise, everything else after this is going to execute, and it is not going to be what you want. Before I let you go, I want to show you that you can actually group these case statements if this is what is making sense for your application. So for example, for rectangle, circle, and ellipse, these can be grouped into the group of shapes. So we can actually say case rectangle and put them on different lines, something like this. So let's delete this and say case rectangle, and we're going to delete the other things and say case circle, just like this. And we're going to say drawing shape. I think this syntax is supported in C++. Okay, so let's try and build. And we're going to build with GCC. And the build is going to be good. So if we have eraser, which is what we have in here, we're going to say drawing shape. Let's clear and run Rooster. You're going to see drawing shapes. Moving on, we have grouped different cases and handled them with one block. And this may come in handy in some situations. One thing you should keep in mind is that there are limitations on what you can use as an expression or a condition in your switch statement. And that has to be an integer, something like int, char, unsigned, short, or things like that. We have seen all of these things, but it can also be an enum. But enum is something we haven't learned about yet. We will learn about it later when we have enough tools to understand that, but know about this limitation. So if we came in our project in Visual Studio Code, for example, and say std string name and say John, for example, and use this as a switch condition or expression, we have to include string for this to work. So let's go up and include the string library. We're going to do string. And if we go down again and try to do switch and use name as an expression and take out everything we have in here and try to compile this, you see that the compiler is not happy. Okay, it's going to say expression must have an integral or enum type. So this is not even going to compile. This is a limitation you have, and you have to make sure what you pass as a condition here is an integer. Something like int or char or other integral types we have learned about in this course. In this lecture, we're going to learn about ternary operators. And this is an alternative way to do tests with the if statement. Suppose here we have a variable called max. We have two variables called a and b, and we want to find the maximum between these two things. One easy way we can do this is say if a is greater than b, we're going to store the maximum in max, else then b is going to be the maximum, and we're going to store that in our maximum value, and we're going to print this out. If we do this, we're going to get whatever is the maximum between a and b to be printed out on the console, and this is going to work really well. But we can also use a ternary expression, and a ternary expression looks like this. And it starts with a pair of parentheses. You're going to put your condition inside the parentheses. You're going to follow that with a question mark. You're going to put your option 1, and after that, you're going to put a colon and option 2. And because this is a statement in C++, we're going to end this with a semicolon. Here is an equivalent version of that using if, as we have been doing all along. So we say if condition result equals option 1. If condition is false, result is going to be equal to option 2. And this is exactly the same thing we are doing with our ternary expression here. If the condition is true, we're going to take option 1 and assign that to result. If it's false, we're going to take option 2 and assign that to result. So this is really a syntactic sugar or a shorthand for this thing here, and it's going to make your code shorter, and you're going to see this all over the place in C++ code out there. So you really need to be familiar with this. Okay, so here is our example of computing the maximum. You see that we have the same variables, max, a, and b, but we have a one-liner that is going to store the maximum and max, and we can print this out. And hopefully you can see that this is shorter and better than this. Okay, one other thing you should know is that option 1 and option 2 should be of the same type, or at least the types must be convertible. And if that fails, you're going to get a compiler error. We can also do ternary initialization. Here we have a boolean called fast. We initialize this to false. We can use this to initialize our speed variable here. We are basically saying if fast, initialize this with 300. If not fast, initialize this with 150. And we're going to print the speed here. And this is going to work. And here you see that I lied a little bit in my explanation to make it really obvious what we had in our ternary expression. You don't have to always wrap your condition in parentheses, but it makes the code much cleaner. Okay, now that you have an idea about these things, it's time we headed to Visual Studio Code and actually tried this and saw for ourselves. Okay, here we are in our working folder. The current project is ternary operators. We're going to grab our template files and put those where they belong. It is in this lecture here on ternary operators. And we're going to open this up in Visual Studio Code as we always do. We're going to open this, and we're going to open main CPP and take out whatever we don't need. We are going to go down and put in our test code. We basically have a few variables. Let's kill these spaces so that our code is not cluttered here. And we're going to print our maximum, and we're going to be using a regular if. We have three variables, max, a, and b. We are saying if a is greater than b, we're going to store the maximum in max. Otherwise, we're going to store b in max. And this is going to allow us to print whatever is the maximum between 35 and 20. If we build this, let's bring up a terminal. And we are going to build with GCC as we always do. Let's bring this up a little bit. And we're going to clear and run Rooster. We're going to see that the maximum is 35. If we put our maximum in b, we're going to get the maximum still. So we're going to run the task to build with GCC. And we're going to run this, clear, Rooster. Max is 200. So we're going to get the maximum regardless of where it is stored in A or B. This is how our code works. But we can use ternary operators to do the same thing. So what we're going to do here, we're going to comment out our if statement and use a ternary version. So what we're going to do, we're going to say result equals, and we're going to say A greater than B. We're going to put a question mark to signal the start of our two options. Option 1 is going to be A, because if A is greater than B, then A is going to be the maximum. So we're going to grab A here. And if A is not greater than B, then B must be the maximum. So we're going to put that as a second option here. This is what we mean with this statement. And we don't have a variable called result. That's why we have a problem here. We're going to put our result in max, and this should solve this problem. You see the squiggly lines go away, and we can build this, and we're going to get exactly the same result. So this is our ternary operator. If we build this, it is going to go through, and if we run this, we're going to get exactly the same result. Max is 200, and it is what we expect. Okay, so take some time and really make yourself familiar with this syntax. It is really nothing complicated. You just have to make sure your brain is aware of something like this, and you're going to recognize it everywhere you see it in code out there. Okay, we have mentioned that you can't pass types that are not compatible. And the requirement is that A and B be of the same type, or at least types you can do conversions between. So for example, if we try to do something like pass a hello in here, we can't really turn a string into an integer, and this is going to give us a compiler error. And let's look at the error we see from Visual Studio Code. Operand types are incompatible. Int and const char are not compatible, and they have to be compatible. If we ignore this and go ahead and build, we're going to also see an error from the compiler, and it should be the same error. So operands to question mark and colon have different types, int and const char, and they have to be things you can really compare. So for example, we can take out this string here and put in a floating point. Let's put in a 22.5 and say that this is a float. You're going to see that the problem is going to go away here. Let's wait for a minute. It's not going away. We're going to build anyway. You see the build is good. We're going to clear so that we don't have all this clutter. You see problems went away. And if we build again, let's try to do that. The build is going to go through, and if we run this, we're going to get max is 22 because we are comparing A and 22 here. And the compiler inserted an implicit conversion from this floating point to integer. That's why we are seeing this here. So what is the type that the compiler really used here? Okay, to make it really clear what is going on, we're not going to use max here. Let's say auto max1 and see what the compiler is really deducing to. So we're going to take this out, and by this we're going to see what implicit conversion the compiler really did here. Because what we had before, we were doing an assignment, so whatever was on the left was being turned into an integer because we were doing an implicit conversion from an assignment. So whatever is on the left is turned into the type of whatever we have on the left of the assignment. I hope you know this already. But if we do things like this, we're going to deduce whatever is on the left and assign that into max1. So we're going to see the implicit conversion that the compiler did in here, and it is good to be able to see things like that. It is a curiosity thing. So let's see what happens here. We're going to print max1, and we're going to build with GCC. This is going to go through, and we're going to see what is printed. So let's run rooster, and you're going to see that the implicit conversion happened from int to float, and we deduced the float here in max1. So this is really interesting. One might have thought that we had a conversion from float to int, but it was actually the reverse, and this is quite interesting. This is really all we set out to do in this lecture. I hope you found it interesting. Again, make sure you have this syntax here drilled in your brain, because you're going to be seeing this a lot in your career as a software developer, not only a C++ developer actually, and it is going to be helpful for you to know this. Congratulations on hitting the end of this chapter. This chapter was all about flow control, and we had the chance to learn about many of the tools that C++ provides to do conditional programming. And we were able to see all kinds of crazy things. We had the chance to do things like, if red is true, we're going to run the code inside. If yellow is true, we're going to run code inside. If green is true, we're going to run code inside. And we had a chance to play with those things on many occasions. We have seen that the tools that C++ provides really revolve around these four things here. We have if statements. We can do else clauses on these if statements. We can do else if to really do long chains of things where we do different decisions to do things in our applications. We also saw that switch is an option if you have several decisions you can make in your application. And we saw that a ternary operator can really be used to do two decisions. If you have two decisions, you're going to be able to reduce the number of lines you used to do these decisions to one line. And we had a chance to really look at that in detail in the lecture on ternary operators. This is really all I had to share in this chapter. I hope you found it interesting. We are going to stop here in this lecture. In the next chapter, we're going to start and learn about loops. Go ahead and finish up here and meet me there. In this chapter, we're going to be learning about loops. And this is a construct that is provided by the C++ programming language to allow you to do repetitive tasks relatively easily. Suppose we have a task to print a message 10 times. We can go down and do it like this and it is going to work. But what if they try and tell you, do this 100 times? Then you're going to start scratching your head, you're going to type this 100 times and you're going to run your program and it is going to work. Then your manager comes up and they say, I want you to do this 10,000 times or even 100,000 times. And then you're going to start pulling your hair or running around breaking things because that's impossible to do. Not to worry here. C++ provides a way to do this relatively easily, and we're going to be learning about ways we can do this in our program in this chapter. The constructs we're going to be using are these you see here. There is a for loop, a range-based for loop, a while loop, and do while loop, and we can make use of these tools to not go crazy printing a message 1 million times because that's really bad. Okay, so that's what we are up against in this chapter. We're going to be learning about these loop constructs, and you're going to find that they are really cool for your application. I am excited to be teaching you this, so let's get started in the next lecture and learn about the for loop. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about for loops. For loops are one of the constructs we have in C++ to do repetitive tasks. They allow us to do something like this much more easily. For example, we don't have to type stdcout I love C++ 10 times or 100 times. We can do this in less than 5 lines, and you're going to see how cool this is. The syntax for loops look like this, and it may look intimidating for first users, but we're going to break this down. We have a few parts in here. The first part is the iterator, which is a variable that we're going to be using to navigate through the loop. And that variable is this unsigned int I here. We are going to initialize this to 0, and the value we initialize this with is going to be our starting value. And that's another key point of any loop. Any loop is going to have a starting point. We are also going to have a test, which is going to control when our loop ends. For example, this loop is going to start with I equal to 0. It is going to keep doing stuff until I is no longer less than 10. As long as I is less than 10, it's going to keep doing whatever it is we want to do. And the first part of the loop is this plus plus I thing here. And this is an incrementation part. That's how I'm going to call it for simplicity, but it is a part that keeps changing our iterator to make our loop move forward. After these 4 points, we are going to have a pair of curly braces, and inside these curly braces, we're going to have the body of our loop. And this is the code we want to execute multiple times. And inside this loop body, we can really do all kinds of crazy things. You're going to see how cool this is. Again, we have a few parts with our loop. We have our iterator, which is this variable I here. We're going to be initializing this with a value that denotes where we want our loop to start. We then have a test, which is going to control when the loop is going to end. We're going to have our incrementation part, which is going to allow our loop to move forward, and it's going to be doing that through incrementation or decrementation. But to make explanation easier here, we're going to call this part the incrementation part of the loop. After that, we're going to have the body of the loop, and it's going to be within these curly braces, and it's going to be whatever it is we want to execute inside this loop. Okay, these are the parts of a loop, and you need to keep this in mind. Okay, now that you know the main parts of a loop, how does it really work? Let's go through this and see how it's going to print I love C++ 10 times. So when this code gets executed, we're going to start with I equal to 0 because that's what we are initializing this value with. After the incrementation part, we're going to run the test, and the test is going to say is 0 less than 10, and that's going to be true. So if the test turns out to be true, we're going to jump into the loop body. And if it's false, we're going to jump to the end of the loop and execute whatever is after our loop. This is how it works. So if we jump in for the first time when I is 0, we're going to print I love C++ for the first time. Then after the body is executed, we're going to execute the incrementation part. This is going to make I equal to 1. Then we're going to come back to the test. We're going to say is 1 less than 10. That's going to be true. We're going to come in the body and print I love C++ for the second time. After that, the incrementation part is going to run. We're going to have a 2 inside I here. 2 is less than 10. This is going to be true. So we're going to fall in the body again and print I love C++ for the third time. We're going to keep doing this until we hit 9. For example, if we increment and get a 9, we're going to fall in the test and say is 9 less than 10. That's going to be true. So we're going to fall in here and print I love C++ again. And after that, we're going to run the incrementation part again. This time, I is going to become 10. We're going to do the test. 10 is not less than 10, so the test is going to fail. And we're going to fall on the outside of the loop here. And by that time, we will have printed I love C++ 10 times. And this is really how a loop works. For the first time, we're going to run this initializer part here to initialize our iterator, which is this value I. And then after that, we're going to run the test. If the test is good, if it's successful, we're going to fall in the body. We're going to execute whatever code is in the body. And after that, we're going to keep doing the cycle increment test body, increment test body, increment test body until we hit a point where the test fails. And if the test fails, we're going to fall outside this for loop here. We're going to execute whatever is after this closing curly brace. And this is how a loop works. I want you to go through this one more time by printing I love C++ and making sure that this is printed 10 times. And one thing you should have noticed now is that we use this test to control how many times the loop is going to start. For example, if we wanted it to run 20 times, we would start from 0 and end at 20. And you don't always have to start from 0. You can really start from anywhere. For example, you can initialize I with a value like 30 and end when I is equal to 55. Let's say that as an example. You can really do anything. The main important thing is to understand how a loop works. One thing I want you to notice is that we are saying unsigned int here to declare our iterator. Iterators are a common thing in C++ code, and they're not just used for loops like we are doing it here. There is a type we use to do iterators, and it makes our code much more readable, and that's called size t. This thing is a representation of some unsigned int type in your C++ compiler. This is going to be different from compiler to compiler, but for example, on my system, this is 8 bytes. So it has quite a good range of values you can put in there. If we use size t type to declare our I iterator here, we're going to say something like this. For size t I, we're going to put our curly braces, we're going to put a semicolon, we're going to put our test, and we're going to put our incrementation part. And I think I really emphasized this, but the parts of our loop inside these parentheses are separated by semicolons like this. So we have the iterator declaration, we have a semicolon, we have the test, we have a semicolon, and we put our incrementation part. And then we go on and put our curlies, and inside we can do whatever it is we want to do inside the loop. So size t is something you're going to see a lot. Make sure you know what it means. Remember that it is a representation of an unsigned int type, so it can only represent positive numbers, and it is used to represent things like sizes in C++. Think the number of students in a classroom, for example, that can never be negative. Think about the number of seats in a car. That's something that is always going to be positive, and it won't make sense for that to be negative. So for those kinds of things, we can use size t to represent the size of those things. And you're going to see how this works in a minute. Okay, now that you have a pretty good idea about how a loop works and the main parts that make it up, I want you to know that you can also do all kinds of crazy operations inside the body of your loop. For example, here we are printing out the current value of our iterator, and we're going to print the double of that. We can do this. We can also leave out the curly braces, and this is only valid if we have one statement we want to run in the loop. So this is going to print this message here 5 times because this loop is going from 0 all the way to 4. It is going to stop when I stops being less than 5, and this is going to be 5 times. If you go through this, you're going to see that this is going to print 5 times. You should also know that this iterator that we are declaring like this is going to be scoped inside the body of the loop. So you can only use it inside these curly braces. And if you try to use it outside, for example here, after the closing curly braces of the body of the loop, you're going to get a compiler error. Again, you can only use this variable I, which is our iterator, inside the curlies that mark the start and the end of our loop body. If you want the iterator to be usable outside the scope of the for loop, you can do something like this. You can declare your iterator outside the loop, and you can initialize that with whatever you want. And then you can set up your loop like this. You can say for j and put in your test and your incrementation part, and inside do whatever it is you want to do in the body of the loop. If we do it like this, then j is going to be usable outside of the loop, and we're going to see its value if we print it out like this. So this is also something you can do. You can even go all crazy and leave out the declaration part if you happen to have the iterator declared outside. So if you do something like this, it is also going to work. Okay, the last thing I want you to see before we head over to Visual Studio Code and actually try this out is that it is a bad thing to hard code your values in. For example, you see here we are saying j less than 10. This is really bad design because every time you need to change the number of times that your loop is going to run, you're going to have to hunt for these loops and change these values. And this may be in a lot of places in your code. So a good thing to do is to put the value that controls how many times your loop is going to run in a variable like this. We're going to store that value in this count variable. Notice that it is of size t because it is a representation of the size of things, something we don't really want to be negative. And we're going to use this in our test part of our for loop here. Instead of saying j less than 10, we're going to say j less than count. And if we want to change this, we have one point of control to go and change this value here. And this is really good design. You should do this. Okay, we have talked a lot about loops. It is time we headed over to Visual Studio Code and actually tried these things out. Here we are in Visual Studio Code. The current project is for loop here. We're going to grab the code from our template project and we're going to put that in place here. And we're going to open this in Visual Studio Code. So let's do that pretty fast. For loop, that's the current project. We select it and we open this in Visual Studio Code. We're going to open up our main CPP file, which is going to show up here. And we're going to remove things we don't need here. So let's remove that. Okay, the first thing I want you to do is the bad way to do things. Again, if we want to print I love C++ 10 times, we can do it like this. And if we run the program, it's going to work, but this is really bad design because you would have to copy and paste this, for example, 1,000 times or even 100,000 of times, and that's really bad. So if we bring up our terminal and build with GCC like we always do, the build is going to go through. You see, it's successful. We're going to clear and we're going to run Rooster and it's going to say I love C++ 10 times. If you count this, it's going to be 10 times because that's what we're doing here. But this is really bad design. You don't want to do something like this. So we're going to comment this out and do this better using a for loop. Let's say that this is the bad way and we're going to use for loop, which is the good way, sorry. So we're going to start by declaring our iterator. So we're going to say for. We're going to say size t. Let's use unsigned int to show you that you can use that. And we're going to say I, and we're going to initialize this with a 0. And this is going to be the declaration of our iterator. This is the first part we have in this parenthesis here. We're going to put in a semicolon and put in the test. We want the loop to run 10 times. So it's going to run from 0 to 9. We're going to stop when I stops being less than 10. This is one way you can understand this. After we have our test in, we're going to put the incrementation part, which is going to change the iterator to make the loop move forward. And we're going to do that by incrementing our iterator. After that, we're going to put a pair of curly braces, not angle brackets, and we're going to fall inside the body of the loop. This block here, delimited by the curly braces, is the body of the loop, and inside here, we're going to put whatever we want the loop to run. So we can go down here and say, I love C++ 10 times, let's say that. But before we do that, let's say I, so that we know the current iteration where we are at. And we're going to put a colon and say, I love C++. This is going to be better to follow in the terminal, I guess. And we're going to put in our new line character, move to the new line. And we need to put our stream output operator here for this to make sense to the compiler. And this is our loop. Now if we run it, we're going to see exactly the same thing like this, but we're going to have these iterators prepended to the message so that it becomes easy to follow this. And again, how this is going to work, we are going to run our code to declare and initialize the iterator. After that, we're going to do the test. We are going to start with I0. So 0 is less than 10. This is going to succeed. We are going to fall in the body here. And after that, we're going to print stdc out, I love C++, and this is going to be 0. We're going to increment I, and we're going to do the test again. We're going to have to do is 1 less than 10. The test is going to be successful, so we're going to fall in here, and we're going to print a 1. And we're going to run the incrementation part again. We're going to run the test, and we're going to keep doing this until we hit a point, for example, when we increment this to be a 9. And after that, we're going to run the test. We're going to say, is 9 less than 10? The test is going to be successful. So we're going to fall in here and we're going to print 9. And after that, we're going to increment again. We're going to run the incrementation part and we're going to make I a 10. If we run the test, we're going to say, is 10 less than 10? The test here is going to fail. We're going to stop running the loop altogether and we're going to fall on the outside of the loop and say, loop done. Let's say that so that we can see this on the terminal. And this is going to run and print I love C++ 10 times, and we expect I to go from 0 all the way to 9. Try to run this in your mind. Take a piece of paper, try to print this as you fall into the body of the loop. You're going to see that's exactly what is happening here. So what we're going to do, we're going to build this again. So we're going to run the task to build with GCC. The build is good. We're going to go down and run this. We're going to clear and run Rooster. And you're going to see that we have 0, I love C++, all the way to 9, I love C++. Our loop is working exactly the way we want. Okay, so this is the first step. We are able to run our code a lot of times without really having to manually do things like this. And the benefit of this is that if we want this to run, for example, 100 times, all we have to do is change our test to go until I is equal to 100. And we're going to stop when I stops being less than 100. And if we run this, we're going to see the message from 0 all the way to 99. And this is pretty cool. The total is going to be 100 times. So let's build again to show you how cool this is. We're going to run this task to build with GCC again. And we're going to clear, run Rooster, prepare to be amazed, run, and it's going to run all the way to 99. We can change this to even 1,000 or even 10,000. Why not? We're going to build again, and we're going to be successful, and we're going to clear and run Rooster, and this is going to go all the way to 10,000 times. We're going to wait for this to get there. Now 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000. It's going to go all the way to 9,999, and it is going to stop. And the total of times the loop run was from 0 all the way to this stopping number here. Okay, now we can see that our loop is really working fine. We don't have to do this stdc out statements a crazy amount of times. Okay, and the benefit again is that regardless of the number of times the code here is going to run, our loop is going to stay relatively the same. It's just going to be 1, 2, 3, 4 lines of code, and this is really cool. Okay, so I think this now makes it very clear how loops work. So we're going to comment this out and show you another thing. And we're going to show you that you can use size t to actually denote the type of your iterator. And it is easy to do that. So we're going to say use size t. And for us to be able to see all this here, let's hit this file icon here to close this pane. And we're going to have a better chance of seeing our code here. So what we want to do, we're going to declare a loop. We're going to say for. We're not going to say unsigned, and we're going to say size t. And this is going to be the type of our iterator. We're going to say I. We're going to initialize this with a 0. And we're going to put a semicolon, like we just did. We're going to put in the end test. We're going to put in the test. So we're going to say I less than 10. No problem with this. And we are going to increment to put in place our incrementation part. We're going to fall in the loop. We're going to say stdc out. This is the code we want to run. So we're going to put in our current value for the iterator. And we're going to say I love C++ again. And we're going to put in our new line character. And if we build and run this, it's going to build and run the same. So let's say loop done here so that we know when it's done. And we're going to build and run. We're going to build with GCC. The build is going to be good. And what we're going to do, we're going to clear and run Rooster. And this is going to say I love C++ 10 times from 0 to 9. Again, the message here is that you can use size t to represent the type of your iterators. And this is a type that is even used in the C++ standard library. So this is going to be something people expect from your code if you are representing sizes in code that should be compliant with the C++ standard library. Nothing stops you from using unsigned int like we do here, but we're just going to follow the convention from the C++ standard library and use this type here to represent our sizes. And some of you might be wondering, how big is this thing? We have the tools to know how big it is, so let's do that pretty fast. So we're going to go down here and say stdc out, and we're going to say size of size t, and we can print this out. And let's say what we are doing here so that it is easy to use this code as the reference. And if we print this out, we're going to see the size of this thing on the system where this code here is going to run. So we're going to build with GCC again. The build is going to be good. We're going to go here and clear and run Rooster. You're going to see that it is 8 bytes on my system. So you're going to have quite a huge range of numbers you can put in here because this is going to only be positive. Okay, if you try to put in a negative number, you're going to get an underflow, and we have learned about overflow and underflow in a previous chapter. Okay, so let's comment this out and keep learning more things about for loops. Okay, the next thing I really want you to focus on and learn is the scope of the iterator. And we're going to grab our code again here so that we can use this as a learning tool. So we're going to go down here and put that in. And what we're going to have, let's move this a little bit to the right. I think we can do something like this. I am going to select the entire thing here and hit tab, and it is going to be aligned with whatever we have here. Okay, so we have our loop. It is going to run 10 times. It's going to print I love C++ from 0 to 9. But what is the scope of this I thing here? And the fact is, it is scoped inside this loop here. You might have guessed that. If you try to use it outside the loop, you're going to get a compiler error because it is only usable inside the body of the loop. You can also use it inside the control part of the loop here, but you can't use it outside the loop. So if you try to print I here, for example, you're going to get a compiler error. So let's try and do that and show you how wrong this can be. So if we try to print I here, let's say I to make it clear what we want to print. If we try to do this, we're going to get a compiler error because I is not in scope. It is only in scope inside these curly braces that show the body part of our loop. Okay, Visual Studio Code is showing the problem here. It's saying I is undefined here, so you shouldn't really do this. But if we move on and ignore the message from Visual Studio Code and compile, we're going to get a compiler error, and it's going to say, I don't know what you're doing here. I was not declared in this scope where you are using it. And I think it's even going to give me a line number. It's going to tell me 46. That's where you are doing something wrong. And if we go in our code, we're going to see that this is the line where we are making the mistake. So I is not in scope here. We're going to comment this out and say compiler error, I is not in scope. That's what you're going to get if you try to do this. And the main message is that if you declare your loop like this, I is only going to be scoped in the body of the loop, and that's the only place where you can mention its name and use it. If we comment this out and build again, the compiler error is going to go away. You're going to see that the build is good. Let's clear so that our output here is good. We're going to build again and show you that the build is good. And this is really cool. Build finished successfully. Okay, this is one way we can set up our loop, but there is a way we can make our iterator usable outside the body of the loop. And we're going to show you how you can do that next. So let's comment this out and go down again. And we're going to grab the code because we don't want to type all this again. And we're going to say iterator declared outside the loop. We're going to go down and put in our code. And we're going to align this nicely. And we're going to take the iterator and declare it on the outside of the loop. So we're going to say size t, and we're going to say I, and initialize this to 0. And we're going to say this very clearly, iterator defined outside. And we're going to say in our declaration part of the iterator, we're going to just say I, and this is going to work pretty fine. If we build this, you're going to see that the build is good. And if we run this, it's going to do the same thing it's been doing. It's going to print I love C++ 10 times. And if you want I usable on the outside of the loop, now you can use it. We can grab the code here that was failing in the last run of our code and put that out here. And we're going to align this a little bit. And if we compile this, the build is going to be good. And if we try to run Rooster, we're going to see I love C++ 10 times. We're going to say loop done, and we're going to print the value of I. And you see that if we do things like this, I is going to be usable on the outside of the loop body. And sometimes these may come in handy depending on the logic of the application that you are designing. Just know that this is something you can do in your loops. Okay, you can go even crazier and leave out this iterator declaration part in your loop altogether. So you can remove that. And we're going to show you how you can do that in a minute. So let's comment this out. I don't want to remove code because I want you to have this as a reference if you need to look at this later. So we're going to say leave out. And what you can do is grab the code we had before. We're going to grab it. And we're going to paste that in here. And what we're going to do is take out this I. This can work, and you may see code like this out there in the wild. So we're going to run this task to build with GCC. The build is going to be good, and we're going to clear and run Rooster, and it's going to do exactly the same thing. So this is one way you can set up your loops. Okay, the last thing we need to see about loops is that this test here is using a hard-coded value. And if we needed to change this loop to run, for example, for 1,000 times, we would need to manually hunt for this line of code, change this, and this is really not good design. So what is recommended is to store this value in a variable and test against that variable name instead. Let's comment this out and show you that. So we're going to comment this out and go down and copy this entire thing. I don't think I want to do my loops like this because this is really unintuitive most times. So I am going to declare my iterator inside, and I'm going to copy the code that does that here, we're going to go down and say, don't hard code values, okay? We're going to say that it's really bad. And we're going to go down and show you a better way to do things. And again, right now, we are hard coding in this value, but we can say const size t, and we can call this value count, for example, and we can initialize it with whatever we want. In this case, we want to control our loop to run 10 times. So we're going to put in a 10. And instead of hard coding in this 10, we're going to say count. Okay. And if we build and run it, the loop is going to do exactly the same thing. It's going to print I love C++ 10 times. So let's do that and run Rooster. It's going to do the same thing, but now we have one point of control. If we want this to run for, let's say, 100 times, we can change the count value to 100 times. And if we build again, that's how many times the loop is going to run. And this is much cleaner. So I do recommend you store the values you use in your loops in variables like this, and it's going to make your code look better. So it's going to run 100 times, and this is exactly what we want. This is really all we set out to do in this lecture. I hope you found it interesting. I am sorry that this lecture turned out lengthy because we had a lot of things to talk about. But now I hope you really know a lot of things about ways you can use your for loops to make them do things. And again, many loops that we're going to use in our C++ code are going to have 5 parts. We're going to have an iterator, which is going to be a variable we use to manipulate how our loop moves forward and does things. The starting point is going to be where the loop is going to start. We're going to have a test in place, which is going to control when the loop ends. And we're going to have the endpoint encoded in that test. We're going to have the incrementation part of the loop, which is going to control how our loop moves forward. And we are going to set up a pair of curly braces that are going to contain the body of our loop. In this lecture, we're going to learn about while loops. And this is another construct we have in the C++ programming language to allow us to do repetitive tasks. The syntax for a while loop looks like this. We have 5 parts in our loop. We have the iterator, the starting point, the test, the incrementation, and the loop body. It's just going to be set up differently for while loops. The iterator is declared on the outside, and you see here we have unsigned int I, which is exactly the same type of iterator we've used in the last lecture, but note that you can also use size t here. I am just using unsigned int for this case. After you have your iterator declared, you're going to fall to this part here and say while, open a set of parentheses, and inside you're going to put in your test. After that, you're going to open a pair of curly braces, and inside them, you're going to put the body of your loop. And you're going to do whatever it is you want to do in the loop in there. And after your code to do whatever it is you want to do is executed, you're going to put in your incrementation part after your code. And that's what we have here. And this is the setup we're going to be using for our while loops. Again, we have the iterator declared on the outside, and we can initialize it with whatever it is we want to start with. Then we're going to put in our test. It's going to be within these parentheses. And after that, we're going to set up a pair of curly braces. And inside them, we're going to put whatever code we want to run in the loop. And then we're going to follow that with our incrementation part. And if we try to run this, we're going to run this line. We're going to declare the iterator I, and it's going to start with 0. So the test is going to run, and 0 is less than 10, and we're going to succeed, and we're going to run the body here. We're going to say, I love C++, and after that, we're going to run the incrementation part. I is going to become 1. We're going to run the test again. So 1 is less than 10. We're going to succeed. We're going to fall in, print I love C++. We're going to increment again. Then we're going to have a 2 in I here. We're going to run the test again. We're going to say is 2 less than 10. That's going to be true. So we're going to be successful. We're going to fall in the body of the loop. We're going to increment and get a 3. We're going to test against our 3 value. 3 is less than 10. We're going to succeed. We're going to print I love C++. We're going to increment again. We're going to test again, and we're going to say is 4 less than count or 10. We're going to be successful, and we're going to keep running until we increment and get a 9. Once we get a 9, we're going to run the test again, And we're going to say is 9 less than 10. That's going to be successful. So we're going to fall inside, print I love C++. We're going to increment and get a 10. And if we run the test again, we're going to say is 10 less than 10. That's going to fail. And we are going to fall on the outside of the loop. And we're going to run whatever code is on the outside here. This is really how a while loop works. And I hope you can see the similarities between the for loop we have seen. It is really the same thing, we just have different syntaxes to do these things. Okay, if you look at these things, we really have the same pieces of information. It is just different syntaxes that C++ provides to do the same things. And sometimes you're going to find it convenient to use while loops, and sometimes you're going to find it convenient to use for loops. And you're going to have to decide what works better for whatever it is you are working on. For now, we're going to head over to Visual Studio Code and try this out. Okay, here we are in Visual Studio Code. The current project is while loop. We're going to grab our template files and we're going to go in our project and put those in. And we're going to open this in Visual Studio Code. So let's do that. We're going to open the folder and we're going to work on while loop here. We are going to open our main CPP file pretty quick and we're going to get rid of this. And what we're going to do is remove what we don't need. And again, we're going to show you the bad way to do things. You don't really want to do this manually. We want to print I love C++ 10 times. So we're going to build. Let's bring up a new terminal so that we can use this when we run things. And we are going to build with GCC. Let's do that pretty quick. The build is good. So we can clear and run Rooster. And we're going to have I love C++ printed out 10 times. So what we can do is comment this out and use a while loop like we want to do in this lecture here. And as we have seen with the slides, the first thing we need to do is declare our iterator on the outside. So we're going to say size ti, we're going to initialize this with 0, and that's going to be our iterator declaration. And we're going to say while I is less than the value where we want to stop. And again, we don't want to hard code these values in, so what we're going to say is really const size t, and we're going to call this count and make it uppercase. This is a convention we use to declare constants in C++, but you don't have to make them uppercase. It is just a convention that is going to make your code easier to read for other people. So we're going to put a 10 in here because we want our loop to run 10 times. And we're going to say while I is less than count, and we're going to set up a pair of curly braces, and they are going to delimitate the start and the end of the body of our loop here. And inside we're going to put in whatever code we want the loop to run multiple times. And the code is now very familiar. We're going to say stdc out, and we're going to print the current iteration. And we're going to say I love C++, stdendl for our new line character. And after that, we will need to put in our own incrementation part. If you forget that, you're going to get something really bad happen. We're really going to look at that later in the chapter. But for now, remember to put the incrementation part. And we're going to say ++i. This is really easy. And we're going to say that this is the test. And this is going to do what we want. But let's go down here and say that loop is done when it is done. So we're going to say loop done. And we're going to say stdendl. And before we run this, we're going to go through it and see how it is going to work. So let's click on this file icon here to close this pane so that we have some breathing room. I am going to open a notepad file we're going to use to see these things really happen. When this loop runs, we're going to initialize the iterator here. What we're going to do is put in a 0, and we are going to run the test to see if 0 is less than 10, and the test is going to be successful. So we are going to fall in here and say 0 I love C++. So let's say that here to make this super clear. Inside the loop, we're going to print this message 0 I love C++, and after we execute this line, we're going to increment. I is going to become 1. We're going to go up again and run the test, and we're going to say is 1 less than count, or is 1 less than 10. The test is going to be successful. We're going to run inside the loop, and we're going to print 1 I love C++. That's what we're going to do here, so let's do that. And after we do that, we're going to run our incrementation part again. I is going to become 2. We are going to run the test. We're going to say, is 2 less than 10? That's going to be true, of course. And we're going to fall in the body again and say 2, I love C++. So let's say that. We're going to increment and we're going to get a 3. We're going to run the test again. The test is going to be successful because 3 is less than 10. We are going to fall in here and say 3, I love C++. Okay, so we can really follow this. And we are going to increment to get a 4. And the test is going to say, is 4 less than 10? That's going to be true, so we're going to succeed and fall in the body again. And we're going to say 4, I love C++. We're going to keep doing this, and we're going to increment again. We're going to get a 5. The test is going to run again. We're going to say, is 5 less than 10? That's going to be true, of course. And we're going to run the code to print 5, I love C++. We're going to increment again to get a 6. We're going to run the test. We're going to say, is 6 less than 10? That's going to be true, of course, again. And we're going to print 6, I love C++. And we're going to increment to get a 7. We're going to run the test, our iterator. We're going to say, is 7 less than count? That's going to be true. We're going to print the message again and say 7, I love C++. And we're going to increment again to get an 8. We're going to say, is 8 less than count? That's going to be true. We're going to fall in the body and say 8, I love C++. We're going to increment to get a 9. We're going to run the test against our 9. Of course, 9 is less than 10, so that's going to be true. We're going to fall inside and we're going to say 9, I love C++. And after that, we're going to increment again and we're going to get a 10. Now, if we run the test, we're going to say, is 10 less than 10? And that's going to be false because 10 is not less than 10. And if the test here fails, we're not going to fall in the body of the loop. Control is going to fall at the end of the loop body. And we're going to print loop done. That's what we're going to say here. We're going to say loop done. And our loop will have run 10 times by the time we print this loop done message here. If you count here, you see that the loop is going to run 10 times and it is going to say, I love C++ 10 times, which is really what we want. Okay, I really had to show you this manually so that you can really see what is happening. But now we can build and run this and let the computer do the heavy duty of running this and showing us all these messages. So the build is going to be successful, of course. We're going to run Rooster and it's going to exactly show the same thing we just came up in our trusty notepad file here. You see, it is the same thing. But the beauty is that we don't have to do all these crazy computations again. What we can do is we can even change the count to 100. So it is going to run for 100 times. And that's pretty cool. So we can clear and run Rooster. And it's going to do that 100 times. And that's pretty fast for computers. This is really all we had to share with you in this lecture. The main thing is to learn about the syntax of a while loop. And again, notice that we have these 5 parts that make up our loop. We have an iterator, we have the starting point, we have a test, we have the incrementation part, and we have the loop body. It is just set up differently with a while loop like we can see here. In this lecture, we're going to learn about do while loops. And this is yet another construct we have in C++ to do repetitive tasks. Let's look at the syntax here. We have our declaration of the iterator on the outside. And after that, you're going to say do. You're going to put a pair of curly braces like this. You're going to put whatever code it is you want to run inside the loop. And then you're going to do your incrementation. And after the closing curly brace, you're going to say while, and you're going to put in your text. This is really the structure. Again, notice that we have those 5 parts in. This is the declaration of our iterator, and we're going to initialize this in place, for example, if we want to do that. After that, we're going to fall in the body of the loop. And after that, we're going to do the incrementation. After we run the code we want to run in the body of the loop. And then we're going to do the test later. And the special thing about a do while loop is that it is going to run first and then do the test last. And this is really something you need to be careful about. Make sure that when it runs, it is doing whatever it is you want to do, because the test is going to run after your code has actually run. And you can tweak this to do whatever it is we want it to do, as we are going to see when we hit Visual Studio Code in a minute. Okay, again, one thing you need to keep in mind is that the do while loop is going to run the body of the loop and then do the check or the test, and that may come in handy in some of the applications you'll be doing within your career as a C++ developer. Okay, this is really the syntax we're going to be using. We're going to head over to Visual Studio Code and play with us. Okay, here we are in our working folder. The current project is going to be do while loop. We're going to grab the template files pretty fast, and we are going to put them in our current project. Let's open this up and put them in there. And we are going to open this in Visual Studio Code. Do while loop is our project. We're going to open this, and main CPP is opened up. So let's remove whatever it is we don't need. And we are going to show you the bad way to do things. The bad way to do things is typing your code to do things manually if you want them to be done multiple times. And this is something bad. If we build this and run, we're going to go down and run this. Clear, not that gibberish. We're going to run Rooster, and we're going to get I love C++ 10 times. And you don't want to do something like this. What we want in this lecture is to use do while loops to solve this problem. We're going to comment this out because it is really bad. And we're going to go down and set up our do while loop. The first thing we need to do is to set up the count, because we want to store this in some variable. So we're going to say constant count. And we're going to put in our value, let's put in a 10, not 190. We're going to say 10 times. And we're going to set up our iterator. We're going to say size t, and we're going to say I, and initialize this with our starting point. We're going to start from 0. And what we're going to do is say do and put a pair of curly braces. And inside this pair of curly braces, we're going to put whatever it is we want to do multiple times. So we want to print I love C++, so that's what we're going to say. We're going to put in the current iteration, and we're going to put a colon and say I love C++. And then we're going to jump to the new line with stdendl. And after that, we don't want to forget our incrementation part. So we're going to say ++i. And this is going to be the part that moves our iterator to the next step. This is going to be the incrementation, and this is going to be the iterator declaration. And after the closing brace, we need to say our test. So we're going to say while, and we're going to put in our test here, and we want to keep doing this as long as I is less than count, of course. And we're going to put in our closing semicolon here. Now, this code is going to run 10 times, but let's go through how it's going to run so that you can really see everything that is happening here. Okay, so when this code here is run, we're going to hit the initialization line here. We're going to declare I, and we're going to put in a 0. We're going to say do, and inside we're going to print whatever we have in I and say I love C++. So we're going to say 0 because I is 0 at this point, and we're going to say I love C++. And after that, we're going to increment. I is going to become 1. And we are going to do the test at this time. We're going to say is 1 less than 10. That's going to be successful. So we're going to run the body again. And we're going to say 1 I love C++. Let's copy this and print this again so that we don't have to type this all the time. We're going to say 1 I love C++. And after that, we're going to run the incrementation part again. So we're going to get a 2 inside I. We're going to test and say is 2 less than 10. That's going to be true. So we're going to run the body again and print 2 I love C++. And we're going to increment to get a 3 in there. We're going to run the test against our 3. Is 3 less than 10? That's going to be true. So we're going to fall in the body again and print 3 I love C++. Let's do that. We're going to do the incrementation. We're going to get a 4 inside this I variable here. We're going to run the test. We're going to say is 4 less than 10. That's going to be true, of course. We're going to say for I love C++ when we fall in the body again. We're going to do the incrementation and get a 5. We're going to do the test. Is 5 less than 10? That's going to be true. So we're going to fall in the body again and say 5 I love C++. Let's say that. We're going to increment again. We're going to get a 6. The test is going to run, and we're going to say is 6 less than 10. That's going to be true again. Then the body is going to execute and say 6 I love C++. We're going to do the incrementation and get a 7. We're going to run the test against our 7. So we're going to say is 7 less than 10. That's going to be true. We are going to fall in the body again and say 7 I love C++. We are going to do the incrementation. We are going to get 8. We're going to say is 8 less than 10. That's going to be true. We are going to fall in the body again and say 8 I love C++. We're going to do the incrementation. We're going to get a 9. And we're going to run the test. We're going to say is 9 less than 10. That's going to be true. So we're going to fall inside and say 9 I love C++. And we're going to do the incrementation again. Now we're going to get a 10, and the test is going to say, is 10 less than 10? And that's going to be false. Now the test is going to fail, and we're going to fall after the while loop here. So if we had a statement here that said stdcout loop done, we would print that. We would go down here and say loop done. And this is what we're going to get if we run this program. And again, I encourage you to try this out in your mind. Print this in some file you have on your computer, or you can even use a regular piece of paper, but make sure you understand the flow we go through to get this code to run multiple times. Okay, now that we have done this, we can build this and let the computer do the heavy work for us and run these things multiple times. The build is going to be good. So what we're going to do, we're going to say clear and run Rooster. And it's going to say exactly what we expect. I love C++ 10 times. And then it's going to say loop done. Okay, one thing I want you to see is that the do while loop runs before it does the test. And this may cause crazy things happening in your program if you're really not careful. Let's say that you wanted this program not to run and initialize this thing with a 0 for the count. So it's going to run 0 times. But that's not going to do what you expect with a do while loop, because it runs things before it does the test. So if you run this program, it's not going to just say loop done. It's going to say I love C++ and have 0 value in here, and it's going to say loop done. But that's not going to be probably what you intended by putting a 0 in here. You put a 0 in here if you want this code to run 0 times, or the code in the body not to run. That's another way to say that. But in this case, a do while loop is not going to do what you expect, because it runs before it does the test here. Let's build this and show you this. So we're going to go through. The build is successful. And we are going to clear and run Rooster. You're going to see that it's saying 0 I love C++ loop done. It is running even if we set our count to 0 here. So be sure the do while loop is doing what you want. But if you are careful about this, you're going to have no problems. And if you want the loop to actually not do anything, when you have 0 count in here, you can use the while loop or the for loop like we have seen before. I would like to welcome you in this new chapter where we're going to be learning about arrays. And arrays are a way to set up collections in our C++ program. So far we have been working with single variables. For example, you have a bunch of integer variables. You can even have 10 or 20 variables of integer type, and that's going to be fine. But sometimes you don't want to manage all these variables. It is really desirable to group all these variables into one single unity and manage them as one single entity. And we can do something like this, group them together and give them a name so that we can refer to them or manipulate them under this name here. And C++ has the array construct to help us do this. Okay, so again, if you look in memory how things are laid out, you're going to have a bunch of zeros and ones. For example, here, each read thing is an int. It is 4 bytes in size, and it can be used to represent an int. So if we have a bunch of ints like this, we might want to group them together and give them a name and manipulate them under this name. This is another way to look at what we just talked about here. And again, arrays are a way to do these kinds of things in C++, and we're going to be learning all about it in this chapter. We are going to stop here in this lecture, and we are going to start and look at how you can declare and initialize an array in the next lecture. Go ahead and finish up here and meet me there. In this lecture, we're going to see how we can declare and use arrays in our C++ program. And again, arrays are a facility we have in the C++ programming language to group many variables together and manipulate them as a single unit. For example, here we have a bunch of integers in memory. Each of these read things is going to be 4 bytes in size, so we can think of it as an integer. And we can group them together and give them a name. We call them scores here, and they are going to be living under that scores entity. So if we want to refer to each of these things, C++ provides an indexing system, so we can use angle brackets like this and refer to the first of these integers as 0. So we can go from 0 all the way to 9 here, but your array can even be bigger than this, many times bigger than this. And we're going to see examples of how we can do that. But this is an example of how you can take many variables, group them under one entity, give them a name, and be able to reference each of these things that are under that entity. And now that the idea is pretty clear, let's see how we can do this in C++. The way to do that is to say int. You have to specify the type of your collection. You have to specify the name after that, and then you're going to put a pair of angle brackets like this. And inside those angle brackets, you can specify the size you want that collection to have or that array to have. And after this statement is run, we're basically going to have something like this in memory. We're going to have 10 integers. So if you count here 0 all the way through 9, that's 10 integers. They're going to be grouped together under one logic entity. That logic entity is going to be called scores. And we can go through that name to manipulate all these things that are in this entity. Okay, after your array is declared and you have space for it in memory, basically something like this, we need a way to read data from it. And we're going to see how we can do that. And it is what we have here. For example, if we want to print the first of these elements, we're going to say scores, angle brackets, and specify the index of the first element in that array or that collection of integers that is called scores. Okay, one thing you should really keep in mind is that arrays are indexed from 0. They don't start from 1. So the first element is going to live at index 0. It's not going to live at index 1. So here scores 0 is going to print the first element, and scores 9 is going to print the last element, which happens to be the last in our collection here of integers. Okay, once our array is declared, it's not going to have data in it. There is going to be data in, but it's not going to be data that we put in. So we can think of this data basically as garbage. Another thing I want to bring to your attention is that your array has clear boundaries. When we declare an array like this, notice that we specify 10 as the size of our array. It's only going to have 10 elements inside. And you can see that we have from index 0 all the way to 9. And inside we have garbage data, but we're going to fix that in a minute. What I want you to see here is that you can't try and read outside the bounds of your array. C++ is funny in that it allows you to do that, but if you do that, you're going to get weird problems. For example, your program would crash or do something really bad, so you shouldn't really do this. Be aware of the boundaries of your array. If you try to read data from the outside of your bounds, you may read garbage data. You may even cause failure of the operating system because you don't really know whose memory you're reading. It's not going to be memory that is allocated to your program. So array boundaries are something you need to keep in mind when working with arrays. Okay, we just saw that we could read data from the array using this angle bracket syntax. We can even do that through the loops and read all the elements in the array. And this is how we could do that. And you can see that the loops we learned about in the last chapter are starting to come in handy. Okay, we have seen how we can read data from the array, but what if we want to put something back in? What if we want to write our own data in an array? Well, the syntax is pretty much what you would expect. We also use this angle bracket syntax, but we're going to assign data to that element in the array. For example, if we want to assign data to the first element in our array, we're going to say scores, angle brackets 0, and we're going to assign a 20 in it. And we can assign a 21 into the element at index 1 and a 22 in the element at index 2. And if we do that, we're going to have something like this in our array. So index 0, we have a 20. Index 1, we have a 21. Index 2, we have a 22. And the rest is still garbage because we didn't put in our data. We can also write data in a loop. For example, here we have our array declared, and we're going to loop around putting data at different indexes. Notice that the index is going to be the current iteration we are at. So this is a common way to do things in C++, and you need to be familiar with this. And after we put in the data, we can read that back and make sure that it is the actual data that we put in. And we're going to have a chance to play with this in Visual Studio Code in a minute. So don't worry if some of these things don't make sense yet. But again, the main thing here is this angle bracket syntax. We can use that to either write data in the element of the array or read data from the element of the array. And this is the syntax here, scores angle brackets I. Okay, so far our array has been declared and we didn't really put in data and there was junk data inside. But there's a way you can declare an array and put data in one single statement. And this is how you would do it. Here we have another array. It's going to be grouping double variables. We call the array salaries and we specify that it's going to be of size 5. And we can put these elements in a comma separated list using braced initialization like this, and it is going to work. If we try to print it out, we're going to see these elements here, and you see that we can read this using the same syntax we've learned about. Salaries, we say the array name, we do angle brackets, and inside we put the index of the element we are reading from, and this index is coming from our loop here, and it is going to work. You're going to get these elements printed out. This is pretty cool. When initializing your array, you can leave out elements. For example, here we have an int array. It is called families. It's going to be of size 5, but we are just putting in 3 elements. The rest are going to be initialized to 0 when we do things like this. And this is something you need to be aware of. And we are going to try this out in Visual Studio Code, and you're going to see that this is actually true. It is possible to also omit the size when you are declaring your array, and the compiler is going to deduce the size from the elements that you initialize your array with. For example, here we have in 1, 2, 3, 4, 5, 6 elements. This array is going to have a size of 6. And if we print elements, we're going to get those printed out. Notice here that we are using a ranged-based for loop, and hopefully you can see that it is easier to read data from a collection like this using a ranged-based for loop, because we don't have to set up an iterator, initialize it, do the test, do the incrementation. We can just read the value and use it and be on our merry way. This is pretty cool. It is possible to also declare your array constant, and when you do that, you won't be able to modify elements of that array. That's what it means if you make it constant. You basically want it to stay constant, and you don't want to allow modifications of your array. And we're going to see this in a minute when we get in Visual Studio Code. The last thing I want you to see is that you can actually do operations on the data that you have stored in an array. For example, here we can sum the elements up and store the result back in our variable sum. And this is something you would do, and it might come in handy in many times. Okay, one thing I want you to see before we head over to Visual Studio Code and play with us is that arrays store elements of the same type. Repeat after me. Arrays store elements of the same type. You can't try and store variables of different types in an array. I don't even know how you would actually declare that. And if you try and store a different type than the type that was declared for the array, you're going to get a compiler error. So this is something you should keep in mind, but it makes sense because when you declare an array, you're going to be given a bunch of bytes in memory, and those bytes are going to be collections of data that is of the same type. For example, here we have a bunch of integers. Again, each of these red things is an integer. And if you try to put in something that is smaller or bigger than an int, then the compiler is going to be confused as to how to read these things. So for arrays to work, the types that you store in the array have to be the same, and they need to be consistent. This is something you should know, and if you try to break this rule, you're going to get a compiler error. Now that you know about arrays, we're going to head over to Visual Studio Code and play with them a little bit. Okay, here we are in our working folder. The current chapter is arrays. The current project is declaring and using arrays. We're going to grab our template code, and we're going to copy and move the files over. And we're going to open this thing up in Visual Studio Code pretty quick. We're going to open up the main CPP file and remove things we don't need. And we're going to see how we can declare an array of ints. Okay, the way you do that, you say the name of the array and you put these angle brackets and specify the size of your array. If you want, you can put a space in here. It's really not going to make a difference. And you're going to put a semicolon at the end. The moment this line executes, we're going to have the space for 10 integers allocated to us in memory, and that space is going to be called scores, and we're going to be able to read data from it or even write data back into it. For now, let's see how we can read data. And it is really simple. We're going to use this angle bracket syntax that we just saw in the slides. So if we want to read the first element, we can say stdcout. We want to print it out, and we're going to say scores. Specify the index we want to read from, so we say 0, and we're going to say stdendl to move to the next line. If you have this typed out, you're going to see that this is going to work, and it is going to print whatever is stored in the first element in this array here. And again, I want you to keep in mind the memory structure of your data when you are working with arrays. So what we're going to print right now is whatever junk data is in this first element here. Okay, in here we're going to say that we have in junk data. And let's bring up a terminal so that we can play with this. And we're going to build this with GCC as we always do. The build is going to be good. And we're going to clear and run Rooster. You see that this is the junk value we have in here. We don't have any useful data in here. It's just junk data because we didn't initialize this array. We can also read the element at location 2 and see what we have in there when you run the program. I'm not even sure if it is guaranteed that you're going to get the same data if you run the program multiple times, but we don't really care. We know that it is junk data, so we can't use this in our program. What we're going to do is run this and see the value for the element at index 1. Let's build with GCC. The build is going to be good. We're going to clear and we're going to run Rooster, and you're going to see that at index 1 we have a 0 end. But doing it manually like this is really time consuming, and it is possible to actually do this in a loop. We know the size of this array, so it's a 10, and we can loop around 10 times, printing each element at each iteration. And the way we do that, we're going to read with the loop, and we're going to say for, okay, size t, and we're going to start from index 0. This is really important because arrays are indexed from 0. They don't start from 1 again. This is something you need to drill in your brain. And we're going to put in our test case, we're going to say I less than 10 because we want to go from 0 through 9. And we are going to increment our iterator. After we do that, we're going to have to jump into the body of the loop. And we didn't name our iterator. That's why we're having this squiggly line here. Let's do that pretty quick. We're going to jump into the body of our loop, and we are going to say stdcout, and we're going to say scores. And we need to be careful about how we format this, because I is not something we have. We're going to be getting that from our iterator here. So we're going to print it like this, and this is going to work. No big deal. And we're going to say scores, and we're going to say I. That's going to be our index that we want to print the data for. And we're going to say stdendl. And because we don't want this to confuse us, we're going to comment that out. And we're going to go up and make sure our comment is nice and neat. And we're going to try and run this. And what do you expect to see? Well, we don't have any real data in here. We're going to have some junk data, so it could really be anything we get printed here. So let's build with GCC, and we're going to give ourselves some breathing room. We're going to go down and clear and run Rooster, and you see that this is really some junk data. And if we run it again, let's see that we get the same output. It is the same data in here. If we want to have in some reliable data, we need to write in our own data, and we're going to see how we can do that. We're going to see how we can write data into an array. And the syntax is really simple. So the way you do that, you just say the index for which you want to write data in, and you say scores, and you specify the index, let's say 0, and we're going to put in a 20, for example. This is how you do this. You say 20, let's say scores. We're going to grab the index 1, the first element, and we're going to put in a 21. Why not? And we're going to say scores. We're going to say 2 for index 2, and we're going to put in a 22. Why not? And after we do this, we can print this out or read data with the loop and make sure that the data we did write in is actually in. So we're going to copy this and comment this out because we don't want this to confuse us on the console. And we're going to do that. We're going to come down here and print the data out. Let's say what we're doing here. And if we build this, we expect to see that at index 0, 1, and 2, we have the values 20, 21, and 22. Let's build and see. We're going to run the task to build with GCC. The build is going to go through. We're going to clear and run Rooster. And look at this. Score is 0, 20, score is 1, 21, score is 2, 22, and our data is actually getting in. Now we're going to see that we can also write the data using a loop to make it really easy without us manually doing things like this. For that, we're going to copy what we have here to print data out, and we're going to comment what we had out here. So let's comment this out, and we're going to go down and print the data again. We're going to put in the code here. And before we print the data, we're going to put data in with a loop. So the loop is basically going to be the same thing. We're going to say size ti. We're going to initialize this. We're going to say I less than 10 because we want to loop 10 times. We're going to increment, and we're going to fall in the body of the loop. What we're going to do is write data at the index of the current iteration, I should say. So what we're going to do, we're going to say scores I, and we can really put in anything. For now, let's say we want to put in I multiplied by 10. So we're going to take the current index, multiply it by 10, and we're going to store that in the index at the current iteration. This is what we are doing here. And if we print this out, try to think about what we're going to get here. So at index 0, let's put in a 0 to be super clear here that we are starting from index 0. At index 0, we're going to take 0 and multiply that with a 10. So we're going to store 0 at index 0. The loop is going to run again. At index 1, we're going to take a 1, multiply with 10, we're going to get a 10. At index 2, we're going to multiply 2 with a 10 and store a 20 at index 2. And we're going to keep going and basically have 0, 10, 20, all the way to 90 stored in our array here. So if we print it out, we expect to see 0, 10, 20, all the way to 90. Let's build and see that that's actually what we have in our array. We're going to build successfully. Let's clear and run Rooster. And you see that this is exactly the same thing we have in our array. How cool is that? Okay, another thing I want you to see is that we can declare and initialize an array in place. But before we do that, let's say what we were doing here. We were trying to write data in a loop, and we're going to comment this out because we don't want a lot of confusing output in our console. And we're going to go down and put in the data because I don't want to type all these things. So we can declare and initialize an array in place. And the way we do that, the array is going to store doubles now. We can really declare an array of anything, but so far we had seen that we can do that for int. Now let's try a little bit and show you that you can do the same thing for double types. So we can declare an array of double types. The size is going to be 5, and we're going to initialize that with this data here. So at index 0, we're going to have a 12.7, index 1 a 7.5, index 2 a 13.2, index 3 an 8.1, and index 4 a 9.3. And that's what we're going to have if we print this out. Here we have a simple loop to print it out, and it's going to basically say salary 0, 12.7, and it's going to go all the way to salary 4 and print a 9.3. And this is something you can do if it makes sense for whatever you are designing with C++. We're going to build this with GCC. Let's clear and run. And you see that this is exactly what we expect. Okay, now this is super clear. The next thing we're going to see is that if you don't initialize all the elements in the array, those you leave out are going to be initialized to 0. And we are going to put in a piece of code to play with that. So here we have an array. It's an int array. It's going to be called families, and the size is going to be 5. But we are only initializing 3 elements. And these elements are going to be elements on the front. So elements at index 3 and 4 are going to be left out, and they are going to be initialized to 0 by the compiler. So if we print this out, we expect to get 12, 7, 5, and 0, 0 at different indexes in this array here. Let's build this with GCC. We're going to clear because the build is successful, and we're going to run this. This is exactly what we expect. We have a 12, a 7, a 5, and the last 2 elements are initialized to 0, and this may come in handy sometimes. Okay, let's comment this out. Another thing we want to see is that we can actually omit the size when we are declaring our array and initializing it. So here is a simple example. We have an int array called class sizes. We don't specify the size, but we initialize it. And the compiler is going to deduce the size of this array from the elements we put in here. So if we put in 2 elements, so it's going to be of size 2. If we put in 10 elements, it's going to be of size 10. And this is how this works. But if you do something like this and not initialize the array, let's take this out, for example, you're going to get a compiler error because the compiler now doesn't know which size it's going to give to this array. So be sure to either put in the size or initialize your array like this, and it is going to work. In this case, we're going to have 6 elements in, and you see that a ranged-based for loop is going to come in handy here because we don't really know the size of this array. If somebody comes and adds in another element, let's say 23, the size is going to change, and if we hard code the size in our for loop, the code is going to break. But a range-based for loop is going to use whatever size this array has. So we're going to try and build this. We're going to build with GCC as usual. And the build is going to go through. If we run Rooster, we're going to get the elements. We have 10, 12, 15, 11, 18, 17, 23. If we add a new element, this is going to work. You see that we don't need to modify the loop here to put in the new size. And this is really cool. I like this about range-based for loops. We're going to build again, and we're going to clear, run Rooster, and this is going to give us exactly the data we have in the array. So this is one way you can do things. Another thing we saw is that you can't modify const arrays. So let's do an example here. For example, we're going to grab this thing and put an array declared down here. We're going to copy that and use that here. And we're going to make this const. Let's give it a name. Let's say birds, for example. For example, we want to keep track of lines of birds or whatever. This is just an example to show you that you can't modify this array. So if you try to do something like birds and index 2, for example, and you want to change this to an 8, the compiler is going to complain. You see that Visual Studio Code is complaining already. Expiration must be a modifiable value. So it is saying that the array stores const elements, so you can't modify elements of this array. Okay, so this is something you can do if you don't want people to be able to modify data in your array. And the last thing I'm going to show you is that you can do operations on the data in an array. So let's bring up our scores array again. So we're going to go up and copy it because the code is using it. So let's put in our own scores array. It's going to be pretty fast. And we're going to say that it is an array with these angle brackets. We're going to initialize this. Let's put in a bunch of values. And what we can do is sum these things up. We're going to store our result in the sum variable. And we're going to loop around with a range-based for loop because we don't really know the size of this array. It can change anytime with however many elements. And a range-based for loop is really cool in that we don't have to keep track of the size ourselves. So we're going to go in here and get each element and add that to sum. So for example, for the first time, sum is going to be 0 because that's what we initialize it with. We're going to get into this loop here. The first element is going to be 2. We're going to add that to 0 and get 2. We're going to add a 5. We're going to get a 7. We're going to keep adding these elements. And at the end, sum is going to contain the sum of all these elements in the array here. And this is one cool way you can sum up the elements in your array. So if we run this, we're going to get the sum printed out. Let's do that pretty quick. We're going to run the task to build with GCC. And we have ourselves a compiler error. What is happening here? It's going to say redeclaration of scores. Where did we declare scores before? Let's go up and make sure it is not declared somewhere, and it is declared here. So we want to comment this out, come back to our code so that we can see it, and we're going to build again with GCC. And now the build is going through. We're going to clear, and if we run Rooster, score sum is 37. And if you sum these things up, I'm sure you get a 37. This is really all we set out to do in this lecture. I hope you have a better idea of how you can declare your arrays, put data in, read data out of those arrays, make them const, or even do all kinds of operations on them. And this was really what this lecture was all about. We are going to stop here in this lecture. In the next one, we're going to see a cool way we can use to get the size of an array. Go ahead and finish up here and meet me there. In this lecture, we're going to see a way we can query for the size of an array at runtime. If you remember in the last lecture, we had an example like this, showing how we can declare an array and initialize it in a single statement like this. But the problem we had with this is that if we tried to print the array using a for loop, for example, we would have to use the size. And the size of this array may change if somebody decides to add elements or remove elements. Then the size is going to be irrelevant. C++ provides a way we can query for the size of an array at runtime, and we're going to get the real size accounting for the current number of elements that we have in the array. And for that, we use the stdsize function. This is a function that comes with the C++ standard library, so you're going to have it already if you have a compliant compiler. If you see here, you see that it was introduced in C++ 17, and it is a cool addition. We can use it to make our code easier to work with. If you look here, we have a simple loop which is going to print data out. It is going to loop starting from 0 all the way to the size of the array. You see that we use this to control when this loop is going to end. We then put in our incrementation part, and then we jump into the body of the loop and print the current element in the loop. And if we do things like this, we're going to be able to print all elements in the array regardless of the number we initialize it with. Okay, so this is one way, and it was introduced in C++ 17. But some of you must be asking, how did we do things before C++ 17? Well, we had to kind of do a hack to get something like this. We used the size of operator we have seen a lot of times right now. And the way you use this, if you do size of and pass in the array, you're going to get the entire size of the array. So if we take that and divide that with the size of a single element in the array, we're going to get the number of elements of the array. And this is really what we are doing here. We are setting up a count variable, and we are taking the size of the array and dividing that with the size of a single element in the array, and we are just grabbing the first element because you can really use any element here. And once we have this, we can use this count to do a loop like this, and it is working pretty well. Please remember that you don't have to go through this craziness we're doing here. You don't even have to use std size, because you can use a ranged base for loop and get access to the elements you have in the array, and it is going to work pretty well. Now that you have an idea about this, let's head to Visual Studio Code and actually play with this. Okay, so here we are in our working folder. We are going to be working on this project, size of an array. We're going to grab our template project. We're going to copy the files and put them in place. And we're going to open this up in Visual Studio Code. Let's do that. It's going to open up in Visual Studio Code, and we're going to try and clean it up a little bit. And we are going to declare an array. If we want to print this thing, we need to know how many times we're going to loop and print elements in here. So one thing you might want to do is to say, okay, we have 10 elements in here, so I'm going to loop for 10 times. You might think this is going to work, and it is going to work. If we bring up a terminal and build this with GCC like we usually do, and clear and run Rooster, we are going to get our numbers. This is what we have in the array from 1 to 10. But what if somebody comes and changes the elements we have in here? Let's add an 11 and a 12. And the moment we change this, we will need to come and change the size in here. And this loop here might be buried somewhere deep in your project, and it might not be as easy as it is now to see that we also need to change this. This may be a really big source of hard to debug problems. So what we really need is a way to get the size of the array at runtime and be able to dynamically query for that size and use it in our program. And that's exactly what std size provides. So we're going to say int count, and we're going to put in a value. Let's use a braced initializer. So we're going to say std size, and we're going to pass the array we want to get the size for. And if we do this, we're going to get this size here, and we're going to be looping for this number of times. So we're going to test for I is less than count here. And now it doesn't matter how many elements we have in here, we're going to get them at runtime. We need to only update this initializer here. So what we can do is build with GCC again. Now we're going to come here and run Rooster, and we're going to get the numbers here. You see that we get all the elements. If we take out a few of these elements, let's take out a few of these. Let's leave in up to 7 or 8. Let's build again, and we are going to clear and run Rooster. We're going to get however many elements we have in there, and this is pretty cool. Again, you might ask, how did we do things before C++ 17? Because std size was introduced in C++ 17. Let's say that here. Before that, we had to get the size of the entire array and divide that with the size of each element in the array. And we could use the size of operator to do that. So before we do any of that, we want to play with the size of method to really show you what it does. So what we're going to do is say std cout size of scores, the entire array, and we're going to print that. And we're going to say std cout size of, one element. Let's say scores, and use the first element. This is the easiest thing we can find here, but you can use any element. So we're going to say size of here, and we're going to say scores, and grab the first element, which is at index 0, and we're going to print its size. If we build and run this program, we're going to build and run, and the build is good. We can clear now and run rooster, you're going to see that we're going to get size of scores is 32, the entire array. The size of one element is 4 because we are storing in integers. And I want you to see that 32 is 4 times 8 because we have in 8 elements. So it's going to give you the combined size of all the elements that we have in here if you do size of an array. But if you do size of a single element, you're going to get the size of a single element. So C++ developers were clever enough to see this and see that we could use this information and get the count of elements inside. So we can do something like int count, and we're going to assign a value to this in our braced initializer. So we're going to say size of, we're going to say scores, and we're going to divide that with size of, and we're going to grab scores. We can really use any element in the array, but we're going to grab the one at index 0. And now we're going to get the count stored in our count variable without using std size, and we can uncomment our array here or the code to print the array. And if we run now, it is going to work exactly the same thing regardless of the amount of elements you have in here. Let's put a few numbers randomly, and if we build and run, we are going to clear and run rooster, and we're going to get all the elements in here. And you can really use any of these techniques. Just choose what you feel works better for you. Okay, we are going through all this trouble to set up an iterator. We're going to do the test. We're going to increment. This is really too much work to try and get data from a collection like an array. So what we can do instead is comment out all this hard work here, and we can use a ranged-based for loop as we have seen before, and it is ridiculously easy and convenient to work with. So what you can do is say for auto I, we're going to do type deduction on whatever it is we have stored in our array. So we're going to put a colon and say scores, and we're going to print out the element. So let's do that. We're going to print stdc out, and here we're going to say value. Let's say value in the array, and we're going to say I. And this is going to print all the elements, and we can work with the values inside if we want that. But you see that we have lost the information on the indexes. So if you really need the indexes, you will need to go through something like this. And if you just need the values in the array, ranged-based for loops are going to be really cool. Let's say range-based for loop. And if we build and run this, it's going to work pretty well. So the build is going to go through. Let's bring this up so that we have some breathing room. We're going to clear and run rooster, and we're going to get our elements printed out here, and you see that it is the exact same thing we have in scores here. So this is really all we set out to do in this lecture. I just wanted you to be aware of the std size facility that we have in the C++ standard library. If you don't want to use it for any reason, you can also go in and do the division we did here to get the count of elements in the array. And do your best to try and use ranged-based for loops because they make it easier and cleaner to get data from a collection like we are doing here with an array. We are going to stop here in this lecture. In the next one, we're going to see how we can work with arrays of characters. Go ahead and finish up here and meet me there. In this lecture, we're going to work on an array of characters and show how special they are. You can declare an array of characters just like any other array. So here we have an array called message. It stores elements of type character. The size is 5, and we initialize it with a bunch of characters. If we want to print it out, we can loop like we loop through any other array. In this case, we're going to be using a ranged-based for loop. We say for auto_c, we pass the message, and then we're going to be printing each character in the message. And if we do this, we're going to see hello printed out on the console. We can also modify elements in our array. For example, we can say message1 and change the E here to an A. And if we print out, we should see hello printed out on the console. Nothing really special so far. The cool thing you can do with character arrays is that you can print them to the console directly without even doing the loop. you can do something like this. You can do stdc out, you say whatever you want to do in quotes here, and you're going to print the message. But sometimes this won't do what you expect because only proper C strings can be printed on the console. And what makes up a proper C string? A proper C string has this thing you see on the end here. This \0 is called a null termination string. And it is what is going to tell C++ that we have hit the end of the string and we are going to stop printing it if we are printing with things like stdc out. So this is really important to be in your strings. If it's not there, it may work, but sometimes it's also going to print some garbage characters after this, because what tells stdc out that we have reached the end of the string is this \0 here. If it's not there, it's going to keep printing until it sees one, and then you're going to probably have some garbage characters added to your string, and that's not what you want. So to have your strings printed out correctly, be sure to have in this null termination character here. And if we print it out, we're going to get it, and we're going to see the size printed out properly if we do things like this. But it is possible to get this autofilled for us. If you look here, we have a character array called message2. Inside we have said that we need 6 elements, and we say hello. So we have 1, 2, 3, 4, 5 elements, and the elements we don't initialize properly is going to be initialized with a 0 version of a character, and that happens to be the null terminator of the null termination character. So this is going to print correctly, and we're going to have the \n appended to this for us by the compiler. But be sure you understand the difference between this and this. Here we have specified the size to be a 5, and we are putting in 5 elements, so we have no null character appended to this string. But here we have said that we can put in 6 elements, and we have only put 5, and the compiler is going to autofill in the null terminating character. These two things are different, and make sure you understand the difference. Okay, so now take a look at what we have here. We have a string, we didn't specify the size, and we just initialize it with hello. Someone might think, this is also going to autofill, but it's not, because the compiler is going to deduce the size of this array using what you initialize it with. And you didn't put in a null character, so it's not going to be accounted for. You're only going to have this here, and if you print this out, you may get garbage characters appended to your string here, so be careful. But it is possible to do literal C strings and only say hello like this in quotes, and you're going to get the null terminating character appended to your string here. So if we print this, this is going to print nicely, and this is the recommended way to initialize your character arrays. If you want to put in string data like this, you have to use double quotes. And the cool thing about this is that you can even put in spaces between words like this. It is going to work. This really looks like how you would like to type text and store that in your character arrays. And we're going to be using this a lot in the course. Again, I want to bring to your attention that character arrays are special in that you can directly print them on the console like we are doing here. You see, this is a character array, and we are saying stdc out message4. You can't do this with other arrays. And this is really all I had to share about character arrays. So what we're going to do next is head to Visual Studio Code and play with us. Okay, here we are in our working directory. The current project is arrays of characters. We're going to grab our template project, and we're going to copy the files, bring them in here, and we are going to open our folder. We're going to open the main CPP file, and we're going to get rid of what we don't need here. Let's put in some starter code so that we can start playing with this without typing this too much. So we're going to declare an array of characters. It's going to be called message. The size is going to be 5, and we're going to fill it with characters like this. So if we do this, we might want to print it like we print any other array. We're going to use loops, and in this case, we chose to use a range-based for loop. So we take auto C for character in message, and we're going to print out each character. Notice that we're not adding stdendl here because we want the characters printed close to each other so that we can read this easily. And after this, we will need to go to the next line so that the next thing we print doesn't disturb us. So we're going to say stdc out stdendl. And if we do this, we're going to see hello printed out on the console, but we had to do too much work to print something simple like hello. But let's do this. We are learning. So we're going to bring up our terminal and we're going to build with GCC. Let's do that. The build is going to go through and we're going to clear and run Rooster. You're going to see that it's going to say message is hello, and this is what we expect. And this is really how you would declare an array of characters and initialize it with whatever it is you want to initialize it with. But you notice that it's really not convenient to put data in here. If you want to store a message, for example, for someone, you don't want to do this thing you see here. It's really ugly, it's inconvenient, and nobody would definitely use your program if you required your users to type things like this. So we need to change this, and we will. But before we get there, let's also see that we can change characters in our array. So if you look here, this E here is at index 2. So what we can say is say message, and we're going to target the element at index 2. Oh, it's index 1. Let's use that. So this is index 0, the H, and the E is at index 1. Let's make sure we get this straight. And we're going to store in an A in quotes. Remember, characters are surrounded by single quotes like this. Once we do this and we try to print the array out again using our technique here, we're going to copy the code and we're going to paste it down here just to do this simply. And if we do this, we're going to see the message printed out here to be hello. And the second message is going to be hello with an A because we changed the second element to an A. It's no longer an E. So that's what we expect. We're going to run the task to build with GCC. And we're going to bring this up and clear, and we're going to run Rooster. You see that we have message hello and message hello, and we are able to print things successfully. This is really cool, but we are doing too much work really to print something on the console, and there should be an easier way to do this, and there is. So what we're going to do is comment this out because we don't want noise output in the console when we try to do something else. So what we're going to do is comment out all we've done so far. We're going to leave in our message here, and we're going to try and print it directly on the console. So we can say stdc out and say message, and we're going to print out the message. And take a moment and look at this and try to compile this. It is going to go through, it is going to compile because C++ supports printing character arrays like this, but in most times this is not going to do what you expect. Let's try and run this and see what we get. We're going to run Rooster, and you see that we're lucky to get something that really isn't what we expect. It's printing hello, and you see that we have a bunch of other things, and the reason is what we have discussed in these slides. For character arrays like this to be printed out properly on the console, they need to be null terminated. In other words, they need to have the null character, which is a \0, appended to the string for stdc out to know that it has reached the end of the string. So this is what makes your character strings legal. Now you see that we are getting a compiler error because we have overflown the size of the array. I think that's the message, too many initializer values, and this is exactly what we have done. Now we can try and change this guy to a 6 to say that we have 6 elements in here. This squiggly line should go away. And if we try to build and run, we're going to build with GCC. Let's bring this up a little bit. And we're going to clear and run Rooster now. And you see that now we have hello printed out correctly. If we turn this back to 5 elements and take out the null terminator, we're going to try and build again, and we're going to clear and run Rooster. You're going to see that we get the garbage back. So For your strings to be printed out correctly, they need to be null terminated. That's why it is not safe to print something like this when your character array is not null terminated. I really want you to understand this. So in C++, we have a proper name for these strings that are null terminated. A null terminated string is called a C string because these things come from the C programming language. Okay, and we're going to see a few ways we can set up C strings now. And the first one is to say car. We can call this message1, and it's going to be an array of characters. And we're going to initialize this with hello. Let's copy this because I don't want to type all these things here. So let's copy this and initialize this properly. Notice that we didn't specify the size, so the compiler is going to get the size from however many elements we put in here, and we're going to put in our null terminator here, and if we print this, this is going to work. And we are going to comment this out, and we're going to say that this will give you garbage. Okay, if we come down here, we're going to see that we have a car array. It is called message1, and we have initialized it with data. We have hello, and we have a null terminator here, and the compiler is going to deduce the size. So this is going to be a proper C string, and we will print it correctly. Let's try and build this. The build is going to go through. If we clear and run Rooster, we're going to get our message here, and this is one way we can set up a proper C string. The second way is to actually not put in the null terminator, but let the compiler add that in for you. And the way we can do that, we can say car message2, and we're going to say this array is of size 6. Let's say that. We're going to put in a 6 and fix how we end things here. We're going to put in our code and end this with a semicolon. Now what is going to happen is the compiler is going to see that this array is of size 6, but we are putting in 5 elements. So the remaining slots are going to be autofilled, and it is going to be using null terminators to autofill this thing. If we try to print the size here, we're going to get a 6 because the null terminator is added in by the compiler. Let's try and print the sizes here actually so that you can see these things. So we're going to say size, and we're going to say that size of message1, and we're going to put in a new line character, and this should be what we expect. So what we're going to do, we're going to copy this and put that down here because we're going to be doing the same thing for message2. So we're going to say message2, let's select this, and say size of message2 and do size of message2. So what we're going to see is message1 and message2 printing out, and we expect to see a size of 6 because both of these guys have 6 elements inside. So we're going to run the task to build with GCC and bring this up, clear, Rooster, and this is exactly what we expect. Message1 is hello, the size is 6. Message2 is hello, and the size is 6. And these are a few ways you can declare your character arrays and initialize them with proper data that is going to print correctly with stdc out. Make sure you don't do something like we did here by printing message here because it is not null terminated. This is going to give you a lot of problems. Again, I want to make it really clear that message3 here is not a proper C string because the compiler is going to deduce however many elements we have in here, and this thing is going to be of size 5, and we're not going to have a null terminator, and if we print it out we're going to get some garbage. So let's try and copy this so that we are consistent with what we've done above here, and if we compile with GCC we are going to compile successfully, but we may get weird things if we print out message3 like we do here. And you're going to see that the size is 5 because we only have 5 elements in here. So let's clear and run Rooster, and you're going to see that we have hello for message1, we have hello for message2, but for message3 we have things we don't expect because it's going to keep printing, and it's going to go overbound, and it's going to stop when it hits the first null terminating character like what we have in here. Okay, so this is not safe. Don't do it. Make sure your strings are null terminated. if you intend to print them with stdcout like this. Okay, so working with character arrays like this to print messages and do all kinds of crazy things is nice, but it really isn't convenient. As I said before, you wouldn't expect your users to type characters like this by surrounding them with single quotes. This is really ugly, and it is painful to do if you want to do some productive work. So C++ allows you to use what we call string literals, and we're going to see an example of that down below. We're going to say string literals, and what we can do is car message for. It's going to be an array as usual, and we can initialize it with a string that is surrounded by double quotes. And what this is going to tell C++ is, take these things, break it into characters, and store this in this array here, and make sure you properly null terminate this string here. So if we print the size of message 4, we're not going to get 5, we're going to get 6, because C++ is going to see these double quotes and know that we intend for these things to be properly null terminated, and it's going to add a null terminator. So let's try and print this out so that we really are sure. And we're going to build this with GCC as we always do. The build is going to go through. Let's go up and clear, and we're going to run rooster, and you see that message 4 is hello, and the size is indeed a 6. So this is one way we have to do things, and we can even put spaces and do all kinds of crazy things, and it's really cool. And if we try to build this, we're going to get the proper message printed out. You see the build is good. If we clear and run rooster, we're going to see hello world, how are you doing? And this is really cool. So from now on, if we need to store a string in our program, this is how we're going to do it, because this is much more civilized, and it is how you would really like to type characters in your program. I have said that character arrays are really special because you can directly print them out with stdcout like this. I want to prove this, so we're going to try and declare another array. So we're going to call this numbers, and we're going to make this an array, and we're going to initialize with 1, 2, 3, 4, 5. This is going to do, and we're going to put our closing semicolon, and we're going to try and print this out. We're going to say stdcout and say numbers. Let's see what we get. Let's try and compile this and see what we get. It is not actually going to give us a compiler error, but it's not going to print what we expect. And let's put a message here so that we know that it is this thing we are seeing here. So we're going to say numbers, and we're going to put a colon here. And we're going to build this with GCC. And we're going to clear. And if we run rooster, look out for the output that says numbers here. So let's run rooster. It's not a 1, 2, 3, 4, 5. It's something we don't really know. And we will get to understand what is happening here in the next chapter. For now, know that you can't directly print arrays other than those of characters. If you try to do that, you're going to get weird numbers printed out. And we're going to understand why this is in the next chapter. So let's say that here. Okay, this is really all we set out to do in this lecture. I hope you found it interesting. Character arrays have a few things you need to be careful about, and we try to cover those in this lecture. We are going to stop here in this lecture. In the next one, we're going to try and look at array bounds. Go ahead and finish up here and meet me there. In this lecture, we're going to look at what could happen if you try to manipulate data out of the bounds of your array. We have seen that when you allocate space for an array, the computer is going to give you a bunch of memory locations you can use to store your data. And it's going to be of the size that you have specified or that is deduced by the compiler. So here is an example of an array that is going to store 7 elements. And we have green slots for these elements, and these are the locations we are allowed to manipulate in our C++ program. If we try to go overbound, for example, if we try to modify something before our array or after our array, It might be a memory location that is owned by another program. It might be a memory location that is even being used by the operating system. So bad things can really happen if you try to use data that is outside the bounds of your array. Let's try to look at a simple example here. Here we have an array called numbers. We have 10 slots inside. So we are only allowed to modify the memory locations for these 10 numbers. And if we try to access something outside the bounds of this array, something might happen. But some people say that C++ is really funny because it should be stopping you from doing something like this. But C++ allows you to do this. If you look at code here, we have an array, we have 10 elements in, so the valid indexes we can really use are from 0 to 9. But if we try and access something at index 12, the code is going to compile, and if we run it, we're going to get something printed out. But that's something, this is going to give you garbage data, or you might be even trying to read some restricted memory, and your program is going to terminate immediately, and we're going to say that it has crashed. If you try to write over bounds, the compiler is also going to allow it, but you don't own the memory, so other programs might come and change that memory location, and if you try to read from it again, you're not going to get what you expect. Another thing that could happen is that you try and modify data that is owned by other programs, and you might imagine how bad that really is. So the message here is don't go over your array bounds, and you're going to be playing in the safe zone. Let's head over to Visual Studio Code and play with this a little bit. Here we are in our working directory. The current project is array bounds. We're going to grab the template files and we're going to put them in place. And we're going to open this up in Visual Studio Code. We are going to declare an array and try to read beyond the legal bounds of our array. So let's try and bring up a terminal here, and we are going to build this with GCC. The build is going to go through. You're not going to get a compiler error, but if we run this, we can really get anything. And you see we have a number. We don't really know what it means. And this means that you have read out of the legal bounds of your array. And C++ allows you to do this. And the reason they do this is because they expect you, the developer, to know what you're doing when you try manipulating things like array. And now you know this, and be careful when you are working with arrays like this. So don't go over bounds, that's the message. We may also try to modify data beyond bounds. So let's go down and put in the code to modify things. And I have put a clear message here as a comment to let you know that this is really something you should be very, very careful about. So we're going to try and change that number to 1000, and we're going to try and print it out and see what we get. But this memory location at index 12 is not something we own. So other programs might come and write to this location, and if we try to read from it again, we might not get what we put in here. Even worse, this memory location might be owned by other programs, and if they read, they're going to get what they didn't put in, they're going to get what you put in, and this is something bad. We might try and really go crazy with this. Let's put in a really huge number and see that we can do that. This is a good way to learn, by the way. It's going to compile, and let's try and print what we have in there, and we're going to say this location here, and that's what we're going to say here, and we're going to build. Again, the build is going to go through. You see that we are doing something really crazy. Our array has 10 elements, but we are trying to modify something 1 million memory locations away. And this is really crazy, and C++ allows you to do this. So let's clear and run did we build. Let's make sure we have build. So let's build with GCC and clear and run rooster. Our program is crashing because we are trying to access something that isn't really ours, and you see it has crashed. Okay, for example, if we have something printed out after this, let's say std program ending, so that you can see it is really crashing, and say std ndl. This statement here is not going to print because once we hit this location, we're going to try and modify this, And the program is not going to be able to do that. It's going to crash. The operating system is going to notice that we are trying to do something crazy, and it's going to say, this program is really crazy. It doesn't know what it's doing. I am going to kill it, and it is going to stop. That's basically what is happening here. So let's build again with GCC, and we're going to clear. Let's clear and run Rooster. You see that it's going to try and do this. It's going to try and put a value in here. The program is going to end here. And this is really bad because memory locations you have allocated for before here are not properly released and returned to the operating system. And this is something really bad. So the message is, don't go over bounds. Make sure you are working within the legal boundaries of your array. Welcome to this new chapter, and we are going to be talking about pointers. Pointers are one of the important topics in C++, and they allow you to do some of the things very conveniently, and we're going to be learning about all those tricky things you can do with them in this chapter. But now, I want you to have a basic understanding of what a pointer really is. So far, we have been working with variables like this. We set up a variable in our C++ code. We get to a point where we put a value inside that variable and we could use it. For example, we could print it out on stdcout, or we could even store a value or assign another value to the variable. We've been doing that quite a lot. But there is a point we haven't really been talking about. Those variables have an address in memory. And here, for example, you see that our var is stored at location 1008. Of course, this is a simple example I came up with, but I hope it drives the point home. All the variables you use in your code have some kind of address in memory, and we can grab that address and store that in a special kind of variable, which is really a pointer. So we can say that a pointer is a special kind of variable that stores addresses of other variables. Make sure you really understand this. Here we have a pvar, so it is a pointer. Its type is int pointer, and we denote pointer using this star symbol after our type. If you see something like this, you're going to know that this type is a pointer to int. Its name is going to be pvar because it's a variable, and its value is going to be the address of another variable. You see, it is storing 1008, which happens to be the address of our var here in memory. Pointers and variables we've been talking about can work hand in hand, and we're going to be seeing how this is done in the next few lectures in the chapter, but the basic idea is really the same. Here you see that we have a pointer to int, but you can have a pointer really to anything in your code. You can have a pointer to car, you can have a pointer to double, you can have a pointer to float, even pointers to custom types we haven't really talked about now, but we will learn about them later in the course. Again, a pointer is a special type of variable in your C++ program that is going to store addresses to other variables. That's what it really is. And we're going to start and see how you can declare, initialize, and use them in your code starting in the next lecture. Go ahead and finish up here and meet me there. In this lecture, we're going to see how we can declare and use pointers in our C++ code. In the last lecture, we said that a pointer is a special kind of variable that can store addresses to other variables in our C++ code. And we have seen a slide like this to drive the point home. Now we're going to see how we can actually use pointers in our code. Here is a simple example of how you can declare a pointer variable in your C++ code. You say int. You put a star after the type to mean that this variable is not a regular variable like we have seen before. It is a special kind of variable that is going to store addresses to other variables. And here I have to say that you have to be really careful and only store addresses to valid types of variable in your pointers. For example, this is a pointer to int. It can only store an address of a variable of type int. For other types, if you try and put in their addresses in here, you're going to get a compiler error. Down here you see we have another example, and it's called p fractional number because it's a double. And you see that our pointers here are initialized using braced initializers, and this is going to initialize the pointers with a special address that really denotes that these pointers are not pointing to anything yet. Okay, you can also say that explicitly and put null PTR inside, and this is going to mean that these pointers are not pointing anywhere. You can't really use the values at the addresses where they point. This is the message here. Don't use pointers that contain null pointer. All pointers on a given system are going to have the same size. For example, if you have a pointer to int and a pointer to double, they are going to be the same size because they really store the same thing. They store addresses to variables, and addresses to different variables, even if they happen to be of the same type on the same system, are of the same size. That's why all the pointers you're going to use in your code are going to have the same size. And this is something you should keep in mind. And here is a simple example to really play with that. We have a size of int printed out. We have a size of our pointers printed out, and we're going to compare these things when we get to Visual Studio Code in a minute, and you're going to see that all pointers are of the same size. A question I get from many people is if the position of this star symbol really matters, and I have to break it to you, it doesn't. But I prefer to put it on the left. Some people prefer to put it on the right, but definitely don't put it in the middle. I've never seen anybody do this, but it's going to work. It's going to be legal C++ code. Another thing I see people do, which is really confusing, is to declare your pointers on the same line and do a comma like this. This is really going to be confusing. And now I want you to guess and see what is happening here. Is either int var a pointer or it's a regular int? I want you to keep this in mind. I'm not going to tell you. We're going to try this out actually in Visual Studio Code, and we're going to figure this out together. But now I want you to try and think about it. We're going to leave this question unanswered, and we're going to answer it in a little while. But for now, don't really do this because it's confusing and it's going to make your code less readable. If you have to do something like this, make sure you just put them on different lines and it's not going to be confusing. For example, if you look down here, you're going to know that p number 7 is a pointer, other int var is a regular int, and there is no room for confusion this time. Use code like this and don't put things on the same line like we have on top here. Okay, now we have seen that we can declare and initialize pointers with null pointer. Now is the time to see how we can put actual data in those pointer variables. Here we have a variable which is called int var. It is of type int and its value is a 43. We can also set up another pointer variable, int pointer. Its name is p_int, and we can initialize it with the address of another variable. And here is a new operator we haven't seen before. This ampersand variable here really means the address of this int variable. That's what we mean here. So we're going to initialize this p_int variable with the address of int variable, and this is how we do it. If we go down here, we print int var, we're going to get the value printed out. If we print the pointer directly, we're going to get the address of this little guy printed out on the console, and we're going to see it. Okay, so this is how you can store things in your pointer variables, and what you have to store in has to be an address of another variable. Down here you see we have another variable called int var1. Inside we have a 65, and if you go down here you see that we are storing something else in our pointer variable here. We had in the address of int var. Now we are putting in the address of int var1 using an assignment operator, and this is something you can definitely do. It's legal C++. It's going to work. If we print it out, we're going to get a different address printed out. This is how you can store values in your pointer variables. Again, you can't cross-assign before different pointer types. Here we have an int pointer which is called p_int1, and we have a double variable called double var. We can't take the address of double var and store that in p_int1. This is going to be a compiler error. The variables whose addresses you store in p_int1 have to be of type int. Again, the basic idea is that a pointer is really a special kind of variable that is going to store addresses to other variables. And if your pointer is a pointer to int, the variables whose addresses you can store in this pointer to int can only be ints. If you